goes. Okay, I think I am in live. I have zero clue. I am live. And the music is instantly psyched. Okay, hello. Okay, so let me just open that up as well. There's so many different sections. I am an old person. Okay, so welcome to obviously the first kind of, I don't know, whatever I'm going to call this. I think I've called this building a compiler, a cool compiler, a dapper compiler. The main idea of this is to kind of be able to just like feel around, see how things go, and hopefully it works out pretty well. And we'll see how this goes. So we're going to be writing a compiler, and we're going to start off probably writing a compiler in Rust. We're going to see how this goes, and it should be a bit of fun. I don't know. Okay, I am slow though to get everything set up. Looks good, I can collapse that. Okay, awesome, let's go. So to begin with writing a compiler, basically the gist of a compiler is that you're going to take in some kind of input from basically just some kind of sample file. So we're going to start off by creating some sample file. We're going to call it, I don't know, hello world.dap. Now, if I'm nice to myself, I have already created a dap language for the sake of giving me some syntax highlighting. I don't know how extensive this is. It at least highlights this. And I haven't really decided on any kind of structure in the language, whether or not I want to do types in a specific way or not. I think I'm just going to start writing code for it, and then I can make all of these decisions later on, rather than try to make the decisions really early. Anyway, so these will probably be pushed up on top of GitHub as well, because why not? Yeah, what's the worst that will happen? And I'll push that later. Probably once we actually start getting something that's actually real. So the first thing that we need to do is we need to define obviously our hello world. So I think I'm just going to begin with a very simple hello world, which is just going to be a print line with a string constant. And so the first step is to basically tokenize this. We have to split up into a series of tokens, and tokens are basically just kind of tagged strings. So in this case, for example, the token could be this identifier print line. Then you'd have another token for the open brace, another token for the closed brace, another token for the semicolon, and probably just a single token for this entire string here. Even if this string is composed of like multiple escape characters and things that kind of break it up a bit more, it doesn't really matter. You still probably have it under one string kind of token. Now I've written a lot of compilers in my past, so I'm going to try to basically just write it and go a bit slower and explain kind of the steps as we go through it. Hopefully this will be pretty interesting. I don't know how slow I'll go. I think I'll probably start off much slower than I'll get it going, just because, you know, I haven't really decided a lot of things, so I still have to kind of visually decide how I want the structure to look, and so I'm gonna chill. I'm not really gonna race too much with this stuff. Anyway, we should be able to get basically most of it done in the next couple of hours, or at least like the framework. Whether or not we get it outputting or being able to execute anything is a completely different matter. So the first step is to probably think of an AST structure. So I'm just going to create a class in here called ast.rus, or RS rather. And so the idea of this is that we want to kind of create some kind of, I don't know, series of structures, I guess. And the point of these structures is to basically just represent our language as kind of a tree, right? And so what we're going to do is we're going to take in our input, for example, print line. Let me not type it out and just do this. Print line, hello world. And we're going to split up, as I said, to tokens. So for example, we would have a token for print line. I'm actually going to call them by the token names. This will be an ID. Then we'd have a left bracket. Then we have a string constant. You can tell I'm very good at typing or writing. And then you have a right bracket. And for the sake of clarity, actually, I'm not going to call these LB and RD. And I'm going to make this a bit easy to read. So it's just going to be ID. This will be a left bracket. This will be a right bracket. And then this can be a semicolon. Okay, so they're basically our components that we're looking at. and they're going to be a kind of a breakdown of our string here. And the next step obviously is to compose these strings into AST. And so the typical way we do this is not really what I'm going to do, I think, here. I think I'm going to kind of play around with it a bit more. I've been thinking about it, and I've been wanting to do this for ages and no real excuse, and so this is my excuse, is helping other people learn how this stuff works. And so basically the idea of this is going to be creating a kind of a different kind of AST. So typically with this AST structure, you'd kind of have some generic kind of program, and then this generic program would have like a decal list, right? So this would be like a list of declarations. So for example, functions, variables, stuff like that. And then you would have a list of functions, maybe separately, maybe they're also declarations. I don't really know. Who cares? We'll put them under the same banner just for the sake of it. And then this declaration list is basically what's like a linked list, right? And so the idea of a linked list is that you have a value and then you have a pointer to the next one. So it's going to have a concreted value. I'm actually going to change the name of the broadcast. Building a rusty compiler. Building a compiler in Rust. Because I feel like people like the Rust name. Funnily enough. Okay. There you go. Why not? Who cares? So the second thing that we care about here is the decal. So this could be, for example, our function. So, or our variable, whatever we want to do. And then the second thing is obviously going to be the list. So we basically would have another decal list here, right? And then basically this kind of chains along, right? You kind of keep having these chains all the way down. But the problem with this kind of structure is it's very inconvenient, right? And so what I typically do is I do what's called a flattened, I guess what I would call a flattened AST, where you kind of grab all these linked lists and you flatten it into like an array that you store within a single node. But like even that is kind of very annoying to deal with. And the main reason why it comes down to this concept of homo versus heterogeneous structures, which is the concept of whether or not you have a collection and whether or not the types within that collection are all of the same type or whether or not they're different types, right? So if they're all of the same type, they're homogeneous, else they're heterogeneous. And the thing that's really convenient and nice for us to deal with is these kind of, homogeneous structures. For example, it's much easier to deal with an array if they're all integers, rather than if some are ints and some are strings, so you don't have to like type check each one, right? And so a lot of the work, I think, with building this AST to make it really nice to work on later on will be kind of removing those inherent kind of heterogeneous kind of components to our kind of AST. Anyway, so the rough idea of this, that you build your program and it kind of folds down, right? And so you'd have a main function here, for example. This may be your main function, right? Which is scoped by this. And then inside this main function would contain like a bunch of print calls. Now this language is probably going to be a pretty low level language. Not in terms of like the scope. It's actually going to be a very different language. It's not really going to be something that's similar to anything that currently exists. This is something we've been really playing around for a while. But I kind of want to introduce the concepts a bit slowly because they use, it's basically transactions are very critical to this language. It's a very transactional language. So it allows you to do some very cool things such as, well, conceptually it allows you to do these very cool things. I've written multiple versions of this compiler before, but I've actually never written a version of this compiler in Rust. So basically the idea of this is going to be writing this version of this compiler in Rust. I've written ones of this in C++ and so on. And I'm going to change how I write this compiler quite a bit. And yeah, I don't really know why I'm doing Rust other than the fact that it's quite fun to try different languages. And one of the hardest things I have found in other languages was testing a compiler is really difficult. But in Rust, it's really convenient. It's very easy to write tests in Rust. You can write these very, very powerful tests. And there's other reasons too, such as like C++. It's fine, but compile times are getting slower, and Rust is already quite slow with compile times. So like to me, switching is not really a big deal, and the performance gains I get aren't basically irrelevant. There's no real difference between the two, and the memory safety I get from something like Rust is actually more significant when we're talking about compiler, right? Especially when we can like look at like, can we run an interpreter? Like that's probably going to be our first step. And if we're running an interpreter, I'm not having to deal with all those memory issues that you may have to deal with other languages. And at the end of the day, we could always just grab a component that's C++ and just like, just have the front end being Rust, or just ditch it if we feel it's too annoying. I don't know, we'll see how it goes. So the first step is obviously to create our AST. Now I've been kind of fluffing around for a bit. And there's many ways you can create this AST here, and I think, I don't know, I've been kind of fluffing around because I'm still trying to think of how exactly I'd want to represent this. I mean, we could always begin with the Lexer. The Lexer is probably the easiest way, and then we're not going to have to worry about it. Yeah, let's begin with the Lexer. We'll begin with the Lexer, because then we don't have to worry about the issues that you typically have with an AST, which is how are you actually going to represent it. So, yeah, okay, that's nice. I'm going to change how I do this, because why not? Yeah. Actually, you know what? This will work. Because it should be actually quite fun. Yeah, okay. So writing a Lexer is a bit different. So the basic foundations of a Lexer is going to be, we'll need some kind of structure here. So the Lexer is going to grab our input and split up into tokens. Okay. So let's just write that. I don't know. I'm not going to... I think sometimes people can fuss around a bit too much before they start writing some code. Let's just write some code. So we're going to begin by writing our error class. I always like starting with error classes. Now, I will probably want a bunch of libraries. I don't think I'm going to begin with any crazy libraries right now. I think I'm just going to begin with an error class, and then we can go from there. So I will probably want, like, there's typically a class I use called error. I don't know if that's by default or not. I don't never remember. Is that default? Who knows? I guess we'll see. So we're just going to begin with that. And then we can define our errors for our subtypes, and we can define errors here. So one of the most common errors that I will always use will be a file IO error, just because why not? And we can take this, I believe, from the IO error, which means we will need to import IO. So we can use IO here, and then we can take the error from IO. Okay, nice. Then the next step will obviously be using probably a few errors. So the first one being saying like missing expected token. So like we're expecting a symbol. I shouldn't really say token, it's just a symbol. So we're missing an expected symbol. And this is going to be quite important actually. Because obviously, what are some good Rust projects? Hey, yeah, honestly, I've done quite a few Rust projects. I haven't really done that much for probably a year because I've been working, so that's fun. But I really enjoyed writing a to-do list in Rust as my first project ever. Something that was very much like I've never used Rust before, it's the right saying. And the main reason why is because Rust has some really awesome TUI applications. Like some really awesome TUI libraries that make it like really convenient to write kind of user interfaces within the terminal. We're saying like C++ is not so convenient, right? You can do all these crazy things with it. It's really quite easy to do. So it was quite fun from that perspective. I think one that I always recommend though is probably compilers are quite fun. They involve a lot of things. You could also what's ones I've been doing recently? Well, there's a few things. So typically, let's have a look. That's work stuff. Menu stuff. Yeah, so that's a good idea, but that's too front-endy. That's DAP. Let's see, projects. That's the other DAP compiler. I don't know. There's a few things. So I would say probably like a to-do list is probably a good idea. Just starting off like and saying, okay, you have a list of items that you want to accomplish, and you just be able to add to them, remove from them using this like nice UI. And the main reason why is because it actually becomes a big problem, and it's actually Rust kind of in some ways. Yeah, in terminal. I probably won't go more in terminal. Rust kind of UI in Rust is a bit tricky. So for example, if you want to do a UI in Rust, you basically end up using something like GTK. And the problem with GTK is that it's effectively very old, which means your UI is not going to look particularly recent. It's fine, but it definitely does have more of an old feel to it. But I would say terminal would be fine. The main issue with it is that when you're dealing with something like Rust, oh, I don't know what I'm doing. Here we go. It has the concept of like a borrow system. So the idea is that you have like variables and they have a specified lifetime. So for example, you know, just in something like C, right, you have like a main function here, let's say. Actually write C code. And if we define X here, the lifetime of this X variable is scoped to the braces, right? So that's a pretty standard, that's a static lifetime, right? But when you're dealing with more complicated programs, you basically have lifetimes that are much more kind of less trivial, I guess I would say. For example, you could have a lifetime where you have to return a variable and you don't actually know how long that variable is going to live for, but you do know it's going to live for as long as another variable. So for example, if we have a function that's like, I don't know, int lookup from array. So if we have an array here, right, and we're looking up, let's say we always return the first index, right? This first index is basically the lifetime of this object is scoped to the lifetime of this array, right? Especially if we're returning a reference to it, right? And so what that means is that we can actually bind those lifetimes in Rust, and we can say, hey, if you want to use this like pointer, or I mean, you wouldn't use a pointer in Rust, you would say like a box, but whatever. If you want to use this object, the duration in which you have to use this object, the kind of allowed period, is always going to be the same as this array here. So they're bound. So you're not going to run into cases where you deallocate the array and forget to deallocate the int. And you run into issues with the to-do list, mainly because if you're doing nesting, right, and I remove one of the inner nested objects, then the problem is I can't just remove it here, right, because it's got a lifetime that's bound to its parent. And so the lifetime isn't so connected. Rocket RS. Oh, cool. Yeah, web frameworks. I have not used Rocket. I actually do think I want to use Rocket. It's one of those things. I ended up, there was a project I did for recently with a bunch of people for my like final year project, and it's using a, I don't know, it's basically a website. I was going to do a post-mortem on this at some point, and it's a pretty cool website. You know, it's got full text chat support and everything, and it does a bunch of cool stuff. Where's a decent chat? You can do this one here. Like it, for example, does syntax highlighting and like videos and all that stuff. But it also has this concept of feeds. So you can like go here, you can like search for feeds, like I don't know, cats, and you can find feeds that have that similar interest to you, right? And so you can kind of build from that. And it automatically recommends groups. So there's like this whole idea of group discovery and stuff. And so we built this in about 6 to 8 weeks. And we built it using something called Django, right? And React and so on. And it was hell. Using something like Django and Python is just, it's so slow. It's actually pretty performant, but that's just because of the massive optimizations we had to do. But I think rewriting, well, not rewriting, but like building something in Rocket, I'm actually kind of interested in doing that. It's probably something I'm going to look at eventually. I actually think you could do something like Rocket, but yeah. Yeah, so, well, the thing about threads, when you're dealing with threads for web server, right, is you have to deal with the whole user versus kernel threads. So the idea that you're having to deal with whether or not you're threading at like a user space level, right? Where basically you're just switching on the same thread. So you're on the same thread, but every time you reach like a blocking event, like you're sending back the network information or like the file, you're basically just transmitting the files. Every time that happens, you can actually go and jump on another task. So while your system is blocked by something, you can switch. You know, that's called user space threads, right? Green threads sometimes and stuff like that. And that's very important for a web server, because web servers typically block quite a bit. So for example, if you have a SQL database in the background, every time you make this SQL database query, while you're waiting for this to finish, you're blocking on this. And that's the point of like await and async and stuff. They're all user space threading. Kernel threads don't really matter for a web server that much. Yeah. Yeah, it's very hard. I mean, maybe I should probably do something like that then, because I think a lot of people struggle with that. Yeah. But the gist of it is that typically threading is something that web servers don't really deal with too much, other than the whole kind of user space level. They typically just spin up more servers if you need more computing power, rather than trying to use more threads in the box. Which is funnily enough. But yeah, so if we have a missing expected symbol, we probably want like an expected symbol of some type. I don't know. Figure that out in a second. And the one that we found. And so the one that we found could be anything here. And then I probably just wanted to find some kind of token type of that. Now, I don't really know what I want to... I typically like doing it like this, and the reason why I'm going to define a type here and bind my token to this type is because I will want to add things like line information. Like, for example, if you have a token here, this hello world, this token lasts for a sequence of characters. In this case, it's 7 characters, right? And so we want to be able to say what line this kind of token or this object is at, and also, you know, how many characters is it. So if, when we print out errors and stuff, we can print out and say, oh, go to this line, this is the specific place that's wrong. Oh, I hate Rust docs. So I typically... Rust docs are very interesting. I've never been great at learning via docs. I typically just learn by trying something, and then if it fails, I just go, oh well, I'm just going to keep trying until I succeed, rather than doing it manually. What am I looking for? I'm looking for the standard library. That's what I'm looking for. I don't remember the URL. STD. That's it. But like, it's really, really annoying to read. I would say typically the only way I think would be useful to kind of understand a lot of stuff is knowing where it exists in terms of like other languages. So like, for example, if you knew like Python or other languages like that, you go, oh, I need this feature, and then specifically Googling for that feature in Rust. So for example, I mean, this is basically what I entirely do. If I need to look for something, and let's say I want to read a file in Rust, I would go file in Rust, right? I know I need to read a specific file, and then I would just try to cut it down to a specific section, rather than go looking. Because I think if you go looking, there's just too much stuff here. And reading a file, files in Rust aren't great. That's probably my biggest gripe. Anyway, okay, token type. Yeah, what kind of JavaScript? Like React, like just raw JavaScript? Because one of the hardest things about going from JavaScript to Rust, obviously, is going to be the fact that you probably don't understand necessarily all the pointer stuff, right? And all the like craziness around like references and so on. React is pretty good. I do a lot of Vue stuff as well. I like Vue. I don't really have an opinion too much over which one's better. So I'm just going to kind of sketch out something here. And sketch out like this. Do you use functional components, or do you use the class-based stuff? I've only ever used functional components. I kind of joined a bit later in the game, whatever. My brain is jelly because I had an exam at like 7 AM this morning. Yeah, functional components. Yeah, they're I don't know. They're pretty nice. I would say the only gripe I have against them is the fact that I think like there's a slight issue around how they handle memoization, in that it's very manual, which means that you can kind of build a big system and then not realize, even though it's like segmented, you got multiple components and everything, not realize that it's redrawing like a crazy amount of times because you have like state changing. It's very hard to kind of realize that your state is into it. I would say functional components are really the only way you can write it from viewing both of them a little bit. I'm just going to say operators. And what do I want next? Probably just continue going with this. But yeah, React and stuff is pretty cool. And then you end up with, you know, the whole fact of the biggest thing about like React going to like web dev and stuff like that to something like Rust is the fact that you kind of lose the comfort of the React is a very fast iteration speed, right? So you can write a change and it's basically instantly applied, right? It's very easy to kind of sketch an idea and then have it instantly show up. Rust has a lot more ceremony, right? There's a lot more kind of steps that you have to do. There's a lot more like kind of wrapping of things up. You end up with these huge like random unwrapped chains and stuff like that. And so that transition is actually quite interesting. I don't know. I feel like a lot of the time you end up writing a lot more code in Rust. It's better, but it's a lot more code. Characters. Okay. So the idea of this is that we're basically just defining a sequence of tokens, right? So these are what we're going to be matching. So, you know, for example, we have the EOF, which is just the end of the file, right? Or the end of our token stream in this case. It's files just coming from the Unix days of when we actually physically had more of a context of a file. Nowadays, most compilers will read everything in as a string. There's like one big string and then just process on it. Another good language to try is C#. I love C#, probably more than I like Rust. C# really is quite fast, it's quite performant, it's just very easy to write code in, very easy to sketch out ideas, and has a very nice web backend kind of system to it. Now, I'm probably not going to do characters right now, but this is like, for example, just when you have a... Characters don't really exist in JavaScript. They exist in most languages, but not JavaScript. And the basic idea of it is just to have like a code point value to it. I mean, they kind of exist, like you can define something like this, but like there's nothing that stops it to just be a single code point. The big thing about this though is we're storing as what's called a Unicode code point, right? And so the idea is that it's actually 32 bits. And it stores multiple kind of like attributes of a single character. So for example, let's say you have I, and then you have the little kind of squiggly line above it, like an accented I. Wait, can I do that on my keyboard? I can, look at that. So for example, this I here, this is a single character, as you can see. Like I mouse over this character and I get a single one. But it's actually not a single character under the hood. This is basically just Unicode, and so it's composed of like multiple subcomponents, and so we refer to this as a code point. So this would be a single code point, and we could refer to each of the sub things as, I think, graphemes is the typical name. Oh wow, yeah. I mean, I've been doing it for like 6 years, I think, probably. It's been a while. Java, Java's not a nice language. I also started Java in probably 10th grade actually as well, and I did not like it at all. It just was way too much code to do anything in life. And then we're just going to define our postfixes here. Now, one of the nicest things about Rust is the fact that you can do stuff like this. This idea that you can kind of create these enums that have like values inside of them. These are called they're called ADTs, abstract data types. No, that's not right. Numeric data types. That's what they're called. Abstract data types is something else. They're called numeric data types. They must be called numeric data types. I don't think I've ever called them anything specifically for it. No, they're not called numeric data types. What are they called? They're like Haskell types. I felt it was like the same word as ADT, it's just pronounced differently, which is why my brain is wrong. Algebraic data type, that was right, it is ADT. So it's ADT, I was like algebraic in my head, numeric, same kind of thing. Alright. Yeah, okay, so I can kind of explain what it looks like. So the idea here is that you have an enum. So this enum is basically like an enumeration, just like in JavaScript and stuff. It's a sequence of options that are basically compiler defined. So the idea is we're defining an EOF. So what this means is that I can say, okay, give me a token type, and give me an EOF. And this is a specific instance of this token type that is an end of file. I can also say give me a punctuation, right? And define it for like a certain character and a certain kind, right? And I don't really know what these are yet. I'm just kind of making it up as I go. Typically, I just generically throw it together. And so the idea of this is actually a structure. So this is just kind of like if we defined a structure here and we called it punctuation, right? And this had like a raw type, which is a character, and a and a kind, which is a punctuation kind, right? It's basically the same idea. You really haven't changed much here. But the difference is that you're able to put it inside of the physical token type here. So it's just embedding it, right? So it's kind of saying, hey, if your token type is punctuation, you have this data that's tagged to it. Yeah, really cool. It's actually really quite convenient because typically, let's say I'm writing C++, right? Or even actually C is probably an easy way of doing this. The way you'd write it, right, is and this is pretty similar to how you'd probably write it in, it's no public. This is how you write it in like JavaScript. Yeah, I'm just defining how the data is physically kind of structured. So what you would have is you would have like a structure which is, for example, my token type, right? And then inside of this token type, you'd have to define another enum. So you say, okay, this is my physical token type, which I typically call kind. So I typically call my enums kinds, and I kind of, just because it reads a bit better as like the kind of punctuation you're using rather than the type. Like type is kind of a bit conflated, so I like using that different word just to kind of make it a bit easier. And so for example, my token kind here could be EOF, it could be punctuation, it could be operators, it could be whatever, right? I probably should call operator just for the sake of keeping consistency. And then what you do is you would actually define another structure, and this would be like your physical data, right? So you have your type here, and you have your data here. And then you would compose these to actually form the actual structure. So this structure would be composed of a kind and some data. So these are two different kind of members or fields. And so your data is actually going to be what we call a union. Now, a union is basically the difference between union and a structure. So for example, like a class in JavaScript, there's no real difference. There's no real way to kind of have a union in JavaScript, but you can kind of simulate it. And the way it works is that typically structures have their fields laid right next to each other. So for example, you would have, in this case here, the kind is the first 4 bytes, or however many bytes this takes up, and then the data is the next 4 bytes, or however many bytes. They're right after each other, right? And that kind of compose your payload, or your physical data, right? And then the idea of a union is you're going, well, that's kind of wasteful. So for example, with my union here, I have many structs. For example, I could have the punctuation struct, and this punctuation struct contains a raw and a kind. So the raw would be a character, and the kind would be another token type, which I'm just going to put as an int for now, in this case. So then you'd also have your operator, reading operator, you'd have your operator, and your operator is just going to be a character string, so it can be just like a const char operator, right? But the difference is that if we place these right after each other, we're only ever going to use one at a time, right? We're not going to have two of the same data segments of the same kind of data types within the same token, right? They're going to have 2 different tokens. So for example, we would have an EOF token, and then we would have a punctuation token, which would, for example, have a kind, yet say, for example, left braces, and the kind would be maybe punctuation kind left braces, or left brace, sure. And then you would have, for example, an operator like plus, right? And so each of these are separate tokens. And so it's kind of wasteful to put all that data in a single structure and one after another, right? So the union lets us grab our data and kind of interlay it on top of each other. So you kind of get this like vertical placement almost, right? Like they're positioned at the same start address. So it means that you save data, right? You save memory, you save space, blah, 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 right? At the cost of that you can only access one at a time. But the problem about this is it's very unsafe. In C, it doesn't prevent you from going and accessing whatever one you want at any time. So even if I set my type to be EOF, I could still access punctuation. And I could still access operator. It's just that the memory that they're pointing to, like, who knows what's there, and it's just going to be whatever I set it to be, right? So it's kind of can lead to this really undefined behavior and this kind of big problems with how you're accessing your what we call tagged unions. We call this tagged unions. Yeah, you've got your union here and you're tagging it with a kind. And it's really basically the same thing as just having in JavaScript, right? Just having like, let x equals 2. And then going x equals a string, right? The data is changing between x, right? And behind the scenes, I'm almost certain that they have something that looks like this. Like, I'm so certain. In that, like, if I show the Python object source code, it literally has a structure that looks identical to this. Object.c. This is the C. This is Python implemented in C, right? Oh, though it will be fun. Probably not the C. Probably the H would be my guess. Would be a better way of doing it. Let's see. Look at this. We have a type, we have a base, we have some head extra, we have ref counts. Okay, good. We have a bunch of constructors, slots. Okay, that's good. It may be too annoying to find, but I just want to find where the heck is Py object? That's what I want. Here we go, piece of Py object. So, oh yeah, this was what I was looking before. So yeah, the Py object has a few things. So the first thing it has is a ref count. This is basically how it decides when it's going to deallocate the object. It uses something called arc or automated. Could be automatic. Who knows? Automatic reference counting. Right. So the idea is that I don't know. I can Google it and show you that. So the idea is that basically. Yeah, it's automatic. There we go. You have like a number or an integer that tells you how many instances you have, and then when that number goes to 0, it means you have no more instances. It means you can deallocate the object effectively. That's really what it comes down to. And so it's very efficient in that you can kind of allocate a bunch more objects to it, and you don't really have to, handle garbage collection. There's no stopping the world and going and having a look to see what things you have to deallocate. But the downside of reference counting is you get what we call cycles, right? Where you basically have an object that relies on another object, and that object relies back on the original object, and these two basically become like married, right? They both rely on each other, and they're just going to like float through the memory like holding hands in this kind of weird way, and they're never going to be deallocated, because every time the system comes and checks whether or not, the system's never going to actually come and check it, but basically when it gets down to this state, it's going to go, can you free yourself? Are you needed? And it goes, yes, I am needed. I'm needed by A. And when it goes and goes, hey A, are you needed? A goes, yeah, I am needed. I'm needed by B. Right, so they're holding on to each other, and sometimes you can resolve cases like this, but it becomes arbitrarily complex, right? You could have like this very long kind of loop with a bunch of nodes, right? And so this becomes kind of almost impossible because they all basically rely on each other, right? So there's really no way that you can handle garbage collection, not garbage collection, no way you can kind of handle reference counting. And so what we do is we do something called weak reference counting, and so you could mark B as a weak here. And when you mark B as weak, it basically means that it doesn't, like, people can't rely on it to exist effectively, typically. When you say you have a weak reference to something, it means that, like, you're weakly bound to that object. And if that object goes away, that's fine. So, for example, if you have, like, a tree, right? you wouldn't want, if you have connections to your parent and to your children, you wouldn't want them to both be strong. Because if they were both strong, they would just hold on to each other forever and never go away, and your tree would never deallocate. So what you do is the pointer back to your parent becomes weak. And the idea of this pointer here is when it's weak, it means that the child is never going to force the parent to be alive. Which means that if the parent ever gets removed, all nodes will get removed and the whole tree will fall. Which is one of the reasons why building a binary tree in Rust is actually so hard, funnily enough. Is because you can't really use a ref counting solution, and ref counting solutions are pretty typical to how the borrow checker basically works. I mean, not really, the borrow checker is compile time, but in terms of like the semantics of how you design your data structures, it's pretty similar. And so effectively, the borrow checker doesn't really have this concept of like having a weak borrow checking reference. So typically most trees in Rust have to use unsafe, right? Because you can't really like build this object in such a way that it would work that way. And the trees that don't use what we call a cursor approach, where basically you have a cursor, which is really just a pointer that points to the top member, and this cursor can like move down the tree, right? So you're not physically like grabbing references to nodes. You have a reference to a cursor that's moving around. So it's like you're one layer out. And that layer gives you the flexibility to do what you need to do around like kind of handling your tree. Anyway, big distractions at the end. But yeah, this object type object is the type of the object, and then basically there'll be a union somewhere. Probably not in this class. I know it exists in Python. I just can't find it. I mean, I'm sure if I Google union, eventually I would find this idea, right? And you'd be able to find what the union is for the Pi object. I don't know. It's probably somewhere. Who knows? Is it going to annoy me forever? Probably. Who knows? I don't know. I may have a look later. But the idea of that is that would let you say, you have a Pi object type that would be like, hey, this is an int. You would have a Pi object type that would be like, hey, this is a string. Anyway, we've written very little code. Let's go back to it. So we have this concept of our numerics, we have this concept of our characters, of all this kind of stuff. I'm probably going to be very lazy here, and originally I used to actually converting the numbers to real numbers when we were lexing them. Nowadays I've liked it less and less, just because I think it's not so much like it really matters when you do it. And typically the value of the numeric doesn't matter until you build your AST anyway, right? So I'm not too fast. I'm probably just going to keep it as a raw string. It just makes the lexing logic a lot simpler, and it doesn't really matter. And often you don't have type information, which means even doing a convert on this could be potentially not exactly what you want. For example, if it's a very, very long integer, you don't actually know what the type of that integer is yet, right? It could just be like a 64-bit integer or a 32-bit integer, and so it is a bit weird to kind of do a bit early. Anyway, so let's actually start defining these types, these kinds. So the simplest way of doing it is to start off probably by defining a what I would probably call a punctuation kind. I quite like doing it this way, and the reason why is because it lets you abstract really the concept of kind of what the kind of punctuation is. And it's a very kind of different way, I think, than a lot of people kind of approach this. I think one of the biggest problems of compilers nowadays is that people use the compiler techniques that is very recent. They use the techniques from the last couple of years, which aren't typically the best way of defining it to compiler. So sometimes going back a few more years and doing the really classic techniques can be a lot better. Okay, awesome. Okay, so we have these opening closing braces here. And then we also have separators. So for example, separators could be our commas, it could be our semicolons, it could be really anything. And let's actually start by kind of structuring, I guess, our numeric stuff. Now, typically, I like kind of putting some indication of what type the numeric is, but I'm actually not going to even do that nowadays. I'm just going to keep this really simple and actually just make a numeric just a string. Like, hey, this kind of looks like a numeric, but it could also not be one. and we can deal with it later. Okay, then I probably want to define some kind of structure for my Lexer. I will probably want to give it some kind of borrowing references, but I don't really care enough right now, so I'm not going to bother. And we're going to give it a line and a column. Now, this is just the current line of the compiler and the current column of the Lexer, rather. Okay, now I'm going to define these probably as current. Yeah, sure, why not, who cares. Okay, and then I will probably want the actual raw offset within the file. So these are kind of like you can think of like these positions as like the human readable formats. Whereas this is like the raw format. So this is in terms of bytes. Right, when our point actually code points. So the reason why we talk about code points is that, like, for example, like effectively what character index you're at. Now, we will want to change this a bit later on, but I think it's fine for now. And then the first thing I want to do is actually define a sequence of characters. So I said this before, I was going to actually have a string of, basically just like embed a string into the program. And that's all I'm going to do. So I'm going to create an iteration, an iter. I'm going to make it peekable, which basically gives me ability to look one token ahead. And then I'm going to look at a series of characters. And I've got an encoding offset here, which is basically going to be how I decide how I encode my... Basically, you can think of this encoding offset as if you have like UTF-832 or UTF-8, effectively, right? So you have different kind of Unicode formats, and these have different sizes within your file, right? Okay, but I actually hate that idea right now. I wrote that down. I don't like it. I'm going to do it. I'll do it later if I care. Okay, so the next thing I care about is probably defining maybe some other stuff. Like, for example, typically what we do is we define like identifier lookup tables. So these are like, hey, here's a list of all the special identifiers. Here's a list of all the ones that are, you know, for example, plus, minus, and so on, right? We may need that. I don't really care for now. Oh, I did forget. One thing I always forget is to chuck my references on this. Okay. I will actually import. Is it using? It's use, isn't it? Man alive. We'll just import everything from the Lexer. Probably should define a mod. Do I have to do it this way? I don't really want to create like subfolders for this. Why are you being cranky? I guess we're just gonna run you. Fun. I guess we'll just do it this way. No external crate. Oh, I've got to do it this way. I always forget. Alright. Well, can I just like define Alexa? I guess we're in the same mod. I also have to mark things as X. Oh, they're public. They should be exported. I probably don't need to do this. Why are you being cranky? Undercred, clay, or module. Okay, screw it. We will create some mods because I don't want to deal with this way. I think there's another way you can abstract them a bit better, but it's fine. I don't really care enough. I'm just going to kind of... I much prefer just to write some code, actually get some code out there, than I do about being specific about it. So the point of this mod is it allows us to define these kind of modules. So we can say, okay, there's a public mod Lexer, right? And if I grab this Lexer and chuck it in there, you can see it's added effectively. And then that's what this will let me use is say, okay, given this, now I can use my Lexer. This lets me export from my Lexer. And then here, I can use a crate. I should be able to say Lexer. It's really weird how main's being weird here. Or do I just have to like define? Oh, I guess I do. I have to like define and say there is this mod from my perspective. I always forget about that. I'd be like doing that a bit better though. It's fine. There's a different way you can do it, but it's fine. I don't have error. I do not have error. Ooh, okay, let me go grab error. I'm pretty sure error is from this error. So I will need to find a series of external crates. Which means I will want to install this error. Now, I don't know what version of this error I want, so let's open up cargo. And then we can look at this error and see what it looks like. Awesome. Looks good. Can I just say build? Blocking, waiting for file lock on package cache. It shouldn't be blocking in that. Oh, you know what it is? I bet you that my program here is automatically compiling it with VS Coders. Because if you see here, it does have this kind of symbol. Yeah, no, I don't want to run that. But it looks like it's running it. I do have Rust installed as well. I guess we're just going to presume it's fine. I think the one I want is this. I don't know. We'll have a quick look. See if it matters. Let's just reload and run it before it starts. I feel like this is suspicious here. Why is this doing this? I don't trust my Rust extension. I was right to not trust it. It's fine. I would enable it in a second. There you go. I think for some reason it got stuck, but okay, it's fine now. Expected identifier. Yeah, okay, well, I'll give you that in a second. I guess the expected identifier will be a token type, and we'll find a token. Awesome. And these just have to implement debug, that's it. Yep, awesome. It's missing the error attribute. And the benefit of this error attribute that's really, really nice here actually is the fact that we can actually write some really nice errors. So I can say, for example, hey, you're missing a terminating symbol or an expected symbol. Or let's just say this way, was expecting. And then I can say expected, right? Like just as if it was a Rust format, which is really nice. And I can say, however, I found this instead. And it's like, wow, that works. It really is quite nice. And this is just generic. I'm just going to chuck every IO error into this, because there's no point really distinguishing them. I spelled punctuation kind of wrong. Okay, so there we go. We got our punctuation kind. We have our Lexer. We have most things. That's pretty nice. What we're going to look at now is probably... I'm thinking... we're just going to jump in and do some peeking and just try to create our endpoint tokens. I think there's really nothing else here. I do actually want to create an unknown. Just in case, you know, for errors, you know, we want to be able to say, hey, here's your token that we found, and this may be like an unknown token, right? We may have not known what it was. Okay, so the basic idea of our Lex is pretty simple. And so we're going to have an implementation here, and we define our implementation using a, you know, a borrow bound, I guess is what I'd probably call it. And then what we're going to do, and the key thing here is we're bounding these characters. We're saying, hey, if you give me the characters of things to Lex, they have to exist for our entire lifetime, right? Quite important. So the first thing I typically do is I say, okay, you know, if you want to create a list of tokens, which is typically what I want, right? And the benefit of a list of tokens is obviously that you can kind of... So there's like three ways you can approach Lexus, right? So the first way is what I would call I guess, I don't know, like buffer based. So the idea is that you have like this sequence of text from a file, right? So this is your magical file. And this text, you know, goes from this point all the way up to this point. And you're just going to stream in one character at a time to your Lexer, which is then going to, you know, after maybe multiple characters, create a token that you then stream to your, you know, AST or your parser or whatever you want to do, right? Now the thing about this that's bad, right, is that you basically have a constant waiting for file IO all the way through your program. And that's okay, but it does mean you hammer the file IO constantly. And I don't really think it makes a difference if you just load the entire file in. I think we're just going to do that. Most compilers nowadays do it because it really doesn't make a difference if you hammer your file IO at the beginning or halfway through. You know, hard drives are pretty fast nowadays. I mean, if you're maybe reading gigabytes of data, it'd make a difference, but it's going to take quite a while to compile that stuff anyway. And we are writing a fast compiler today. I want my compiler to finish under a minute, but who knows. Okay, so the rough idea is we're going to create a function here called init, or new, I think people typically call them. I don't really care too much. And the new is going to say, okay, hey, if you want to create us, you got to give us a bunch of characters, right? You would have had to already read the file in, or taken it from standard output or whatever. And, oh wait, why am I returning a vector here? My brain autopiloted. And I'm going to return you a Lexer, right? And this Lexer will have the same bounds as these characters here, right? Okay, awesome. And then all we're going to do is we're going to define a Lexer to return, right? And it says, hey, you're missing a bunch of stuff. Okay, so let's add it. So the current line and current column are pretty straightforward. I'm going to start both at 1, because that just is the kind of most logical value for them. The code point offset starts at 0, and our character starts at basically just chars. And then we want to do it as peekable, so I need to convert it to character sequence, and then I need to probably do, yeah, peekable. Reasonably easy to guess, I guess. Thank goodness. Hopefully it wasn't too much more complicated. It's a bit loud. Let's just turn it down a bit. Okay. So what do I want to do next? I don't know. Sure. Have a is punctuation check. So this is all this is going to do is basically check whether or not a given token is punctuation. I typically like doing this. This is what I've written in my notes for to do today. And all we're going to do is we're going to say, hey, if you give me a token, I'm going to return you back a punctuation. Now, I don't really want to do this statically. We're just going to initialize them each time. We can come back and optimize things. So what we're going to say here is we're basically going to go, okay, match C. Now, hey, if C is less than brace, then we have a punctuation type, right? And that's all we're going to do basically this entire time. Instantly, I don't like this. I mean, it's fine. And also, it is punctuation. It's weird. I don't know. So the problem with this, right? Basically, what this all kind of... I really can't write punctuation, my lord. Well, this all kind of, coalesces to... Oh, sure. My brain is very dead today. I probably am gonna take a break in a couple of minutes to eventually kind of refresh myself, and then I'll come back and we can write a bunch more. But effectively, I don't know, man. What do I want to do? I don't love this. I guess it's fine. I really shouldn't care that much. I think I'm just going to create a token type of this punctuation type. And again, wow, I am horrific at spelling, apparently. Now, you can't just do this. You couldn't last time I looked up. Right? I can't do this. Yeah, I can't do variants. That's okay. But what I can say is transform to type. And so what I can do is I can actually transform all these to types. And so this is not the specific token, it's just transforming the character itself. And this can basically transform each of these one by one. So this should be a sum. And the token type here is missing parameters. Yay, okay, good. And then we create punctuation. And it's missing raw and kind. Look at that, awesome. Okay, so the kind is just going to be C, and so the raw is going to be C, and the kind is going to be punctuation kind. Open 0. Now the thing is that we actually do have a kind of a nesting depth that we got to maintain. So what we will want to do is we will want to like update these. And that's actually quite important to update these. So what we'll want to do is basically when we check if something is punctuation, we have to be a bit careful. We have to basically go, hey, is this punctuation? And if so, we have to like maintain a state of the open and closes for each punctuation type. And so I think the easiest way of doing that, the easiest way of doing that is probably to kind of add an extra parameter here, right? So we can have like a hash table. So I'm just going to call this open close state. That makes sense. A slightly better one may be balancing state, like brace balancing state kind of. So this is just going to be a hash table. There we go. And this is going to take in a character and a it's going to produce like a state, a balancing state, which is just really an int i32. Which is actually probably what this needed. Yeah, okay. So my balancing state is going to start off being nothing, basically. And I'm going to just create an empty hash table. Hash map hash table, same thing. And your hash tables allow you to basically map from one character to an integer in this case. And then all we're going to do here is we're basically just going to kind of repeat the same process, right? And we will come back to the whole balancing state. We can actually be clever here. Why are these public? Yeah. I need to provide a self. Fair enough. And I also want to say this is it's a non-mutable version of self. Actually, no, this needs to be a mutable version of self, which is fine. The problem I have with this kind of thing here is I can't really give it a default value. This is probably my biggest gripe with this stuff, right? Is, can I index it? I can. Yeah. Huh. Interesting. Wait, why am I mutable? I can just contain it. Extend, is that what I want? Insert. Sure. It's weird. Awesome. Okay. So if it contains the key, then we're good. Else we want to insert it. Okay. They want actual literal moves of it. Oh, they physically want the value of the character there. Okay, that's kind of weird. Fair enough. And then we can just say return. You're pushing open. I think I do want this to have this return in I32. I thought I could define types and structures. Maybe I've got to define it within the implementation. That makes more sense, but it's kind of weird. Okay, I'm just going to chuck it here. I just don't want to, like, I may want to change this later on to be smaller. The idea of this is just, yeah, I don't know. I also don't really like chucking an I32 here. Okay. Balancing depth. Type is a bit weird. It's fine. I don't really care enough. Okay, so if it contains the key, then all you have to do is basically grab a reference to it. But in this case, we're just going to return 0, which means you can just say 0. In this case here, though, we actually want to grab the value and actually do something with that underlying value. So we do actually want to grab a mutable reference to it. And for that reason, what we could probably do is instead of doing this whole self-contained things, we can actually do something like this, and do a get mute. And the benefit of doing it this way is effectively we get a mutable reference, and we can now access this mutable reference and go something like this. So this allows us to increment this mutable reference by 1. And then, for example, we can just return v like this. Oh, whoops. Okay. And this will basically give us what we want here. So increase it by 1, return the new depth. So for example, if it was 0, now it's going to be 1. And so now, for example, we can, with this one, we can say push open. And we can say C. And open as a U size. Okay, it's just do this way. I understand why I did a U size there, but I don't really think it matters. I don't know, I guess change balancing state push or pop. I don't know, it's kind of awkward, isn't it? It's like mutate balancing state. This music's very sad. Let's do more boppy. This is gonna be too loud. It's gonna kill me. It's a bit better. Okay, anyway, so the idea of this is that we're mutating the balancing state, then we're gonna have like an operator that mutates it. So either pushes it or pops it. But I actually still hate that. I think I'm just gonna do push and pop. Anyway, so that's fine. So push open basically just will infinitely push open. The only problem would ever occur when we're trying to, for example, pop. Right? So we want to pop a close, push balance. Pop balance. It's very awkward. I really don't like these names. It's fine though. And this is going to return the new balancing state after this pop. So obviously the first thing that we want is we actually want to do something like this, but the difference obviously is this becomes negative, and the other thing that we care about is what the actual balancing state is, and if it doesn't exist. Right? So if v is equal to 0, we actually have a problem. Really? Ah! Okay. Thank you, Rust. You're just gonna make me write twice as much code. It'd be okay. Yeah, so this is actually, honestly, it's probably like a... Didn't Rust have a type at one point that was like... I think they removed it, but it was result. No, I think they've still got result. They've still got result, okay. So this actually returns a result. The other one doesn't need to, but push doesn't need to, but this one does. And this result is basically like, hey, is this an error? And this can be like a token error. Lex error. Token depth. This is very loud. I don't know. Is it actually that loud? Let's see. Ah, it's pretty soft. It's very loud for me. I don't know. I guess we'll see. It's pretty fine. Why don't I just like play from everyone? Yeah, it's fine. Listen to myself. Okay. So the misbalanced symbol basically is saying, okay, hey, the token depth, or we can just say like depth for symbol is 0. Cannot close. Can't find. Nice. This is can't find opening symbol. I don't like this, but it's fine. I think it's better. Alright, so we pop it, this is fine, and we can say okay. And we can say yes, it's an error. And the error is a Lexer error of type misbalanced symbol. And the misbalanced symbol is going to be well, really this is just an option none, and this has to like kind of wrap the symbol. But I guess we just like do a raw string here and not care too much. Yeah, sure. Am I going blind? No, it's not. I did type it right. It is kind of weird. Yeah. How do you create it? It's like .toString. Oh, it just doesn't pop up as an error. It's because this implementation has. Oh, okay, wonderful. The fun of seeing Rust a couple of years later. Okay, now we have an error for misbalanced symbol. So in both these cases, it's misbalanced. I don't really like this. This is one of the inconveniences of it. Obviously, I would like to merge this if statement up here, but I can't merge this if statement up here because of the experimental feature. When they drop the experimental feature to let that happen with if statements in the year 3090. We can finally make this nice. Ignore the rest. Okay, now we can actually finally write this push symbol, right? And this pop symbol. And we should actually get some decent errors from this. We'll test them out in a second. Oh, yes, is a result, so I have to do the try, if I remember. Isn't it try? Rust try. I was back in the day of when it was this the symbol. Yeah. Oh, it is this symbol now. Okay, I thought that was the old version. Nice. And then I can pass the Lexer here or here. Okay, that is much nicer. Yay! Okay. And these both become okay. Look at that. Now, obviously, it's going to warn me and go, hey, you're not matching everything. Okay, I'll match everything. And then this can be an error. This is basically an undefined token, right? So we're basically saying we have no clue what this token is, right? Now, we don't really have an error for an undefined token, so let's add it. I don't like using the word undefined. I also don't really like using this kind of stuff here. I guess I should just say can't find opening symbol for symbol. So the point here is to try to make it readable, right? Because you're going to have people reading these messages more than you are going to have you kind of defining them. I don't know. I guess I'm going to say unknown token is fine. Unknown symbol. Stop using the word token. Okay, an unknown symbol will just be like a hey, we ran into our Lexer and we don't know what the heck this is. And so we do have this unknown here. I may remove this just so my token types are simpler and I don't have to worry about like the whole concept of having unknowns leaked to my parser. That maybe make more sense. I think architecturally it's more confusing. It was more complex, but I think ignoring the fact that it's going to be harder to design the code that way, I think it will lead to much better code. I have to go and change my slow cooker settings in a second since I'm making a very nice beef stew tonight. It's been going for like freaking like 10 hours or something. It will be delicious. Anyway, and then the symbol is just going to be the string here. Now I do put string here rather than character, even though it's typically a character, and the main reason why is actually because, well, it turns out there's actually a few reasons, and it really comes down to like how you use it. And so, for example, if we want to use it for things like numbers and stuff, I have a feeling I will want it as a string because I want to be able to say, hey, like this number is like not a number. Like you start off as a number, like you had 0, then like 45, and then you've just added like QZ at the end, right? Like you've defined a number like this. And to be able to say this symbol is invalid, I got no clue what this is, right? Is much nicer than being like, oh, I don't have 0 clue what Q means, right? Anyway, they're probably gonna have a different type for that again. So maybe I'm going a bit crazy. I don't know. I feel like designing code simpler is always quite nice. Okay, Lexer error. And then we're going to say, hey, we're missing a symbol, an unknown symbol in this case. An unknown symbol is just going to be C, which we're going to convert to a string, which for some reason isn't a type, you can see. And then, yay, look at this type. Great. We actually have now this beautiful type here, and we can go, hey, we can transform our type. So we only can, match braces, but at least we'll match braces correctly. And so it's just, for example, have a next token function. Scare myself. And I will go up and be back in a minute. But I'm just going to go and change the settings so it can just be a bit warmer for the next couple of hours. So it can be on low heat so I don't like overcook it. Okay, sweet. I'm just going to go do it now. And I'm back. The potatoes smell so good. They're just like the crispiness on the outside because I crisped them up before I put them in there. And they're going to be so warm and they're going to be like so break a party. It'll be just beautiful. Alright, so the next token function is going to be very simple. Now we will need to take a mutable reference to ourselves here. Now I don't really like doing this in Rust. I think it's typically a bad pattern to have these kind of mutable references everywhere, but they're really quick. And so we'll really quickly do it, then we'll come back and we'll use what's called cells to basically let us say, hey, this hash map, we want to modify it, but we're not really modifying the Lexer itself, right? But we'll also have to update things like positions and stuff. So I may not do the whole cell-based approach with the Lexer. I guess it makes probably more sense. Like the Lexer itself is physically moving. Maybe it makes sense to take it mutably. Who knows? Alright, so we got this is going to be a public function, and this is just going to return the next token, which is really just going to be a result actually, right? And then this result can be passed on to the main function. Okay, now this is just going to basically pass the next token and move the entire state along. There's many ways you can write this however you want, but the general idea is that we want to skip whitespace completely. So we're going to have a skip whitespace function. And we're basically just going to, I don't know. Sometimes I like to pass something extra here. It's fine, probably. Yeah. I don't know. I guess it's fine. You could also, if you want to go crazy, you could actually return like a token that represents the whitespace that you skipped. I don't think I'm going to care. I think I'm just going to literally go while you can let some match equal the next character, like while there's a character to match, right? We haven't reached EOF. If the character is white space, I'm not wrong here, right? That's the right. I'm pretty sure that's the right way of doing it. So if the character is white space, yeah, if the character is white space, then we want to continue. So I guess if it isn't white space, we want to break. Yeah, sure, why not? Then we could. This is where we're actually going to like physically move. You can see here that we're just peeking, right? We're not actually moving ourselves, and so we want like a. So I like calling it like next. Like this is like or consume. Consume is a great way of calling it. So consume basically just lets you skip a, now I probably want to be a bit more specific here. I probably want to say consume character. Because typically I'll have consume tokens and stuff, right? Like that's quite common to have this kind of concept that you can like peek the next token. So there's many ways you can build a compiler, and they basically come down to the idea of having LL1, which is basically talking about like the format of the compiler. In this case, you know, we're saying it's a this is just the look ahead, but I don't remember what this stands for again. I actually took a, what the heck does it stand for again? It's like left something. You know those things where you think you remember what the words for is, but then you just completely forget. Even Wikipedia is just like, it's the LO grammar. It's just like a leftmost. Ah, it's left to right. Yeah, leftmost. It's just a way of passing it, right? You effectively, it's the way you pass it. So, for example, if you have a language that is defined as, hey, you know, for example, your base token's A and this matches to A, and you have base token B and this matches to B followed by A, right? If I give you the sequence BA, then this matches in two ways. So the first way would be what we call, well, I guess it doesn't really matter what way you do it, but it's still the same idea. The first way is, are you going to leftmost match or are you going to rightmost match, right? So obviously it's going to have to be a B token here. That's the match, right? So we're going to match it to B. And then we're going to replace B with BA, right? Now, basically, a rightmost token will actually match this A here first before it matches the B, right? And so what you'll get is it basically will end up, if this is like a really complicated token, let's say, for example, this is for example C, and C points to B, right? And this becomes C as well, right? Before matching this C, a rightmost parser will grab and match the A instead, right? So it goes right to left. A leftmost parser matches the C, which is really what we're going to do, right? We're going to match tokens left to right. Keep things very, very simple. The thing about compilers is that basically the parser and the Lexer is the easiest part of them, and you don't want to overcomplicate it because they're going to be so fast, right? The slowdown of compilers comes basically from two reasons. One, people using Node.js for every compiler on the planet, which is just like super slow, right? Hitting file I/O, you gotta be a bit careful with file I/O, but not typically too much. The problem with like JavaScript compilers is that they have to actually produce a lot of file I/O, right? Where if our compilers that we typically will write here, we're reducing like LLVM stuff, right? And then that's going to go to a different component, which is going to produce executable code that's then going to be ran, right? And so the difference is one of them is actually going to have to produce like object mapping files and like all these extra files. And typically, you know, they're minimizing a lot of content. You've got CSS, you've got HTML, you've got all these different attributes, right? And they're also not particularly written fast, right? But most of the time, the parsing is the cheapest part of the entire process. So really worrying about how you define your parser doesn't really matter. We're just going to do an LL, probably not one. We're probably going to define some kind of K here to allow us to get some look ahead. I typically allow us to have like 1 or 2 tokens look ahead, right? And then I cheat in a few places to give us a few more tokens where we really need it. But I don't typically implement it as like a massive amount. I think typically keeps the compiler a lot simpler if you don't have like these massive kind of backlog buffers where you kind of you presume it's along this path, and then once you reach the end you go, oh, I can't pass this anymore, this isn't correct, and you have to go back like 10 tokens, which actually turns out to basically be the issue with C++ parsing, is that they really can't define the parser well. There's a lot of like complications around how they define the parser. And so you end up defining a really complex grammar, and then that means the parser is really complex, and so on. And It's really, really hard to pass C++ for that reason. Like using the newer features. The older ones are pretty easy. Anyway, so consuming a character is pretty straightforward. All we're basically going to do is we're really not going to do anything crazy. We are going to match it just for the sake of doing it, but we're just going to say, okay, grab the current characters and just move to the next one. That's it. Really, there is nothing else here. Now, I do see this next if, and that's actually making me really... Ooh. Okay. I may actually think about that. But it may be better than writing it this way. Ooh. Anyway, we'll come back to that in a second. So we'll match this next here. And the idea of this is will give us the ability to say, hey, have we reached EOF or have we not, right? And this is basically going to return our token, right? Our optional character. So if we match a character, we're going to return it. Now, it seems a bit weird to write it this way. Because you go, oh, well, can't you just return the character next here? Like, isn't that going to be an optional? And the answer is, well, yeah. But we actually want to do a bit more state to it. So we actually want to do things like update the position and so on. So, for example, our column needs to update. Our line needs to update if we are a new line, right? And in which case our column would reset back to 1. I mean, you could probably write this slightly differently, but it's fine. And then we can actually finally say some C, right? We do have this code point offset that we also want to update. And we're just going to update this by 1. Now, this will basically presume that all our files are UTF-8, right? Which isn't really correct, but it will be correct for now. When we want to change it later on, we will change it. And we'll come back and we'll update this if we ever decide to support UTF-16 and stuff. Basically, you just have to change this increment. Right, that's it. Okay, so the way that I was thinking about writing this much nicer is actually quite nice. So you can say, okay, wow, self.chars dot what is it called? It's like, I thought it was move, right? Next if. Okay, I can't really say like equals, but I can say like, hey, if you have a character and the character is a white space, then translate to that next character. No, but that won't update the line information. And by the way, this would just be like is some. Anyway, yeah. I mean, I'm not going to do it for this reason, for the fact that it's unstable. It's very close to what we want, but we basically need to change the consummation here, the consuming. So I think what we'll probably do is one of the things I do want to do in the future is to grab this concept of the current line and embed it within this peekable. So you define the Lexer itself becomes a stream rather than having this kind of like manual iterator process. It itself becomes a iterator, like basically just an iterator, right? So you can use a for loop on it. Now, using a for loop on a Lexer is really not useful. You typically want to get tokens one by one manually. But like on the actual inner components of that, on the physical characters, updating the state of the Lexer and so on, it does make sense to do that. Whether or not you expose it as that or not, it doesn't really matter. Anyway, so the first step is to skip whitespace. Wow, we wrote a lot of code just to skip whitespace. Then the next step is to actually, pretty much, we're just going to say, hey, grab the next token. And if it exists, then we're good, right? Yeah. And hey, if it's punctuation, I guess transform to type will do all the work here. Sure. I don't know if I would love that right now, but I will use transform to type. And just give it C. Else. Oh, I did want to use consume car. Yeah. And then I can say here, I can put my, this is basically where I could do my, whatever you want to call your EOF. In this case, it could just be a token. Okay. Token type. EOF. And ta-da! We've written a very basic Lexer. And it's really, really easy to build from this. I'm just gonna... Do I have to make these public manually? I do. I'll make these public. I don't really like having too much private around my structures. Too much. Not really in Rust. I'll do it for some things. Like this here, this is like really internal state. This should not be exposed. But like having a getter for like current line and current column is ridiculous. The rule would basically just be don't modify this, right? It'd be great to be able to chuck a read only on this to say, hey, you can only read from this, which is why we have obviously mutable and non-mutable references, right? But you need a mutable reference to move it along, which would also allow you to modify the state of it, right? Which is where it's kind of clunky, and where I think it would be nice to be able to say, hey, this member is read-only from any outside observer, right? Unless you're the implementation. So why don't we begin by actually just writing a very simple Lexer here. So we're going to grab our reference to our Lexer. And our Lexer is going to equal... I love how I instantly wrote it. It's what let mute is to define a mutable reference. It is. Look at that. And then we're going to define a Lexer, and we're going to define one based on new, and we're going to give it a string, and we're just going to give it a series of opening and closing braces and seeing whether or not it can pass all of them. And then we'll go more crazy later. I'm just going to say forever. Wait, why can I access the balancing state? It's not public. Anyway. It's fine. Maybe like all that stuff is still public. I don't know. Who knows? Next symbol is fine. Or maybe it's like public because like I'm within their module or something. Like I've defined their module. It's probably fine. So grab the next token. Okay, if you have a value that's okay, then we have a token, right? And we can do like, what was it, like right line? There we go. And we can say, write my token. I thought that was how you did it. How am I misremembering this? I mean, technically it's print line, but same difference. Right line is what it's going to do on the underlying SD out. I'm not wrong. It's literally how it's written. Format returns a string. I don't want the string. Like, this is literally what I want. Do I really have to do format to get it? I shouldn't have to do format. Yeah, look. Oh, do I have to say like 0 like this or something? I'm just going to ignore it and come back to it. Oh! It's print line. My gosh, it's funny. Oh, yeah. Yeah, it's just me being stupid. You gotta print it, right? Right line takes the first argument as being the stream. Okay, that's convert each of our tokens, and then at the error that's fine. But it's also valid for this token not to be anything, right? So we're actually also going to handle that. And this is just going to be a break, right? It's just going to exit. Okay. So I'm just looking at something. It's pretty good. And yeah, feel free to like follow and stuff if you're kind of enjoying this. We're starting off slow because I want to make sure I've got a good enough scope for it. And then we'll immediately basically just probably next time I start doing this, I'll probably do this tomorrow as well. We'll just immediately run into it. We see a bunch of misbalances. Now we can like debug this. So we're seeing the misbalance symbol here, misbalance symbol here, and so on. Why would this occur? But we actually are seeing the opens. That's really, really good. So the problem here is probably due to the fact that this pop is returning an error, obviously. And it's only an error if it's equal to 0. That's why. And still an error, why? If the v equals 0, you can minus 1. No. Oops, yeah, no, it is if it equals minus 1. Oh, wait, why? Why? What am I doing? It's if it's greater than 1. What the heck? My brain is fried. Yeah, okay, still wrong. Why? If it's greater than or equal to 1, you can subtract 1 to return it, else we do this. If you can get some state from this. If you can't get some state, you can't pop it. Insert some state for that character. And the initial value will be 0. Well, the initial value won't be 0, it'll be 1. It's just this value itself will be 0. Which actually means you want to return that. Because like I want it so that like you got to increment the state here. Otherwise you're going to make a mistake if you don't increment the state. So that's actually the problem here, is that we're not incrementing the state, which means that you're putting in 0 and then you're trying to close 0 and you can't close 0. Like you have to put in 0, but like your current state is 1, if that makes sense. Anyway. And again it's complaining. So this is good because it means this is open 1. Now my perspective is that maybe this isn't actually setting it. I am grabbing a mutable reference to it, so I would presume it would set it. But I mean, who knows? So let's just print it out. Oh yeah, I can't print out within this scope. The problem with print out within this scope here is that I've already borrowed it mutably from this, and V is currently mutably bound. I actually still want to do stuff with V, and so I can't use it. So what I could do, however, is capture V and say, like, for example, this, and then say V here, and this is fine. And the reason why is I'm grabbing a new reference to V, and I'm just grabbing the unwrapped value, and then now I'm no longer mutably borrowing it because I no longer need the actual mutable reference, so now I can immutably borrow it. It's kind of clunky, but it will let me check the value. This is like printing out in a weird order, right? Oh my gosh, I'm stupid. I've got to map it to the other type. Oh, what am I doing? Sometimes, man. Okay, so obviously the problem here is I've got a closing brace. I don't have a mapping opening brace too, right? It's very simple. Balance. That's all you're going to basically do for each point. Right? Over and over again. And I'm not going to worry about any more than these. Okay. Let me just check something on this side. Looks good. Okay. And that's fine. And then if it isn't a match, this is just like, why are you trying to map a balancing operation that doesn't exist? It's like terrible. So this is just I'm just gonna panic. Ah! Don't match. Why are you trying to map a balancing character that isn't a balancing character? You please don't do this. Thanks. Real professional. And then now we can map the balancing character. We grab it. Sure. Like, I feel like I'm back in C. You know what would be quite nice though is other, or I could say like open, is the mapped balancing character. Yeah, I like that. It's funky. And then up here, I don't really want it to be a string. You know what? These can just be characters. Screw it. Good. I think it's stupid that I didn't make them what they are. And dereference these. Okay, great. I think just keep it simple. So we're mapping our balancing characters here. The code looks pretty okay. Yeah, sure. What does it look like now? Look at that. I mean, they all got the same value, but that's meant to be, right? They're all 0. That's good. That's exactly what you want, right? Just keep in mind that like these are all next to each other. There's no nesting. If we nest a bunch, like these are like 2 next to each other, but this one also has like a bunch inside of it. So we have the center one, out. I think that's enough, the balance. Yeah, look at that. Starts at 0, goes up to 1, 1, and then closes 1, then opens 1 again, then goes 2, 3, 4, and then all the way back down again. Yay! We're balancing braces. Look at that. Only took 200 lines of Rust code. But now we can actually match some things that aren't braces. For example, we can match these kind of braces. Wow, look at that. Absolutely insane. We can do these multiple at the same time. Okay, let's get to some more interesting stuff. Let's say, for example, you want to match a character. So you can match 0 to 9. Now, you can't just write like this. I think you can write like this, though. From memory. Range patterns are deprecated. Oh, because I've got to do it this way. Yeah, sure. That makes sense. Okay. And so this is basically then going to be our passing for our number. Now, this actually does kind of consume the character, right? So it's kind of, I don't necessarily think it's particularly great, but I often do this where you can kind of rely on the fact that it's a little bit nicer. So rather than, the reason I don't say it's great is because it's kind of messy, the fact that you have to pass this starting character in to start off the string. But the convenience of it is it means that you basically don't have to backtrack. I don't have to like peek here and then consume and like kind of do that pattern. I can just go, well, I can take every single character that they come in. It's just some of them I've got to include within my buffers, right? Anyway, yeah. feel free to ask questions as we go along or do stuff. I think one of the things we'll do next, someone mentioned Rocket RS, and I'm actually quite interested in that. So I think tomorrow I'm going to look at building a web server in Rust to chuck some of this compilation stuff up so we can compile from the web server for no real reason, just play around with it because it'll take like an hour or 2 hours or something, and could be interesting. Or maybe we'll do something a bit more interesting. I don't know. If anyone has ideas, I'm happy to do it. Okay, so with the 0 to 9 match, we're just going to say pass number. Nothing crazy. And I don't really like... okay, let's just focus on the self.pass number. Starting character being C. And that should be fine. I don't really like doing this kind of thing where you effectively like have braces here and you have a bunch of logic inside of these. I typically like writing my match statements, so it's like 1-to-1, and then you put the logic into other functions. It's not so much like going crazy like OOP, like, oh, let's have a billion classes for things, but it is about like recognizing that you have to like kind of characterize these things a bit better sometimes. Anyway, this is so nice. Like, out of perfection, to have this line is just like very beautiful to read to me. I love lines like this where it just reads very nicely, and having this very nice like error unwrapping here for when you can't pop the symbol. It's just not having to have if statements to pop stuff is so much nicer. Like, this is just ugly because there's nothing really too much you can do around this, having to replicate this error statement here because you can't move this if inside of this let. It's gonna turn into me hating Rust. So a lot of these things do turn into me ranting. Like I've taught a bunch of classes at the uni for various things, and basically probably halfway through the semester, typically 2 or 3 like tutes end up me just complaining about things, which people seem to love. Yeah, I don't know. It's kind of funny. So we're going to pass a number here. I'm going to be really lazy because why not? And the way I typically pass numbers is by just looping through each character one by one and just seeing whether or not they're digit, and that's it. And then you got to handle floats especially, but floats you handle differently. You can handle them however you want though. Anyway, so what we're going to say is we're going to say, hey, well, we can grab a character from this sequence, right? That's not entirely true. We do kind of want to peek. So what may actually be nice is doing something similar to what we did with the skip white space. But I don't entirely... I think what may be nice is just to do something like this. So we can say, like, have we seen... there's 5 people. Wow, look at... That's nice. I think there's even more. Like, I don't know what people call them. Lurkers or some shit? Who knows? Anyway, so... yeah, so if you're enjoying this stuff, you feel free to follow. I don't know, I haven't got any like notifications or anything set up yet, so I don't know if people are doing it, because I am a little lazy. It's not really, I've got a day job and everything, right? Okay, so we can say whether or not we've seen a dot, and this is false, and this is actually mutable, and we also need the same thing for whether or not we've seen a exponential sign, right? So the typical format of numbers is as follows, right? So you have a series of digits, or you have, for example, something like this, right? So this is your floating point number, right? You can also have, for example, something that's a little bit more complicated, like this. You could also have, there's trillions of different formats that you can do, right? And it really is up to you how you want to define what formats you support in your language. You can also support things such as, for example, bases, like this is hexadecimal, and then so on, right? And each of these carry their own complexities. Yeah. Okay, so I don't know. It's one of those like, kind of like boring functions, where you have to like hype yourself up to write it. You're like, oh. Anyway, it's okay. So there's 3 main formats here. I'll write a bit of documentation here just so I feel like I'm not having to like jump into a boring function mentally. Okay, chill. Why don't you like this? Oh, less stock. Okay, sure. So the first, easy match is just a simple number like 29, right? This is just a simple number, it's just an integer, just digits, right? The second one is where you start with a dot, right? And this is a floating point number, dot at beginning. And then there's also a dot halfway through, or at any point way through, like a dot at some point through the number. And then you also have your exponentials, right? With a sign as well, right? Now you will note I don't care about negative numbers here. And the main reason why is because negative numbers are really just going to become a unary operator. So for example, -1 is not going to be incorporated as a -1. It's going to be basically done like this. It's a literal 1 with a negative unary operator applied. And same thing for +1. It just makes life easier. So the first step, I guess, is to check the scene dot. So if start is equal to dot, then we have a scene dot, right? This is just so we don't say it twice, right? And then we're basically, I guess, just going to loop. Kind of awkwardly, I guess. It's kind of weird, right? Who knows? Sure. We'll just do a while loop. I always like writing my loops as loops. So this is like a nice trick. If you don't really know how you want to write the code, and I don't really know how I want to write it here, because it's kind of, I can't like use a for loop really. Like a for loop is like really classical in C, you just like use a for loop over it. But here it's a stream, right? I don't have a length. I can't just like keep going. I have to like kind of check whether or not the next token is valid and then grab it, right? So if you don't really know how you want to structure it, just create a loop and then you can always refactor it in a second, right? Okay, so the first thing is to match. Right? And grab the next token. If it's a, for example, a plus sign, or maybe it's a negative sign, right? Then we know this is only valid if we've just seen an exponential, right? So we could handle it here. We could handle this like plus sign, negative sign. I'm not going to. I'm going to handle it a bit later on, like inside the E. So instead what I'm going to do is I'm going to say, hey, if you see an E, or you see an uppercase E, you know, who cares which one you choose, then what we're going to do is we're going to read and see whether or not you see the next stream. And the one big thing that you'll see here is I'm actually going to do something like this. I'm actually going to grab a mutable reference to number, and then I'm going to push characters onto it. Again, I'm not trying to pass this integer here, or the float here. I'm simply trying to validate if it is a number. The passing of it can happen later, and it's actually very easy for the passing to happen later, right? Because we can just check whether or not this string has an E or has an dot, or we can literally just like give a suggestion of what the type could be. Like, there's nothing stopping us here from having a raw string value here, and then having a hint that basically says, is this an int or is this a bool? There's nothing stopping us, right? Right? And later on, guess what? We could add hexadecimal. And so on, right? To our hints. So effectively, we're keeping them as in the raw format as much as possible, which will mean that if the floating point we need higher precision, we're not converting it too early and losing precision, right? For example, who knows, maybe we want to sport something in our language like this, where you say, hey, I want you to find a big int, and then you give a floating point number, right? Or, sorry, big float. Now, this floating point number, the precision, even if I use like a double, like a 64-bit precision floating point number, it's not going to be as good as if I use arbitrary precision. So if I convert it now, I've actually lost precision. And it's better to wait until the big float passes it. But rather than forcing what most languages do, which is force it to be a string, I can actually still add validation and still say it has to be a number. It's just that the actual interpretation of what this number means can happen later. And even in my AST, I don't need to transform it to an integer yet. Right? I probably will, because it's convenient, but I don't need to. Right? Especially if I want to do things like this. Right? Anyway. The basic motto of how I make things fast is delay doing expensive things until you need to do them, and cache everything. And typically programs are pretty fast when you do that. Because memory is really cheap nowadays. Like, who cares if your program takes half a gigabyte of memory? At the end of the day, like, it really doesn't matter. I mean, it doesn't matter if you're building like Spotify or something, right? But it doesn't really matter if you're building a web server, because typically web servers, like, you're going to chuck so much RAM on that thing anyway. If it uses like an extra 100 megabytes, it's not really a big concern. It depends what you're obviously facing. Anyway, so okay, if this is a dot, I'm gonna come back to the other one. Alright, if it's a dot and scene dot is false, right? And guess what here? And scene exponential is false, right? Okay, if we're all the way through and we're at the very end, the question is basically, hey, is this a valid token, right? Can I put something here? And the answer is actually yes. So for example, 2.2 plus 9 is valid. Now, the number is 1.2, then we have a token, which is a symbol, then we have another token, which is the 9. But we have to be able to support this format, right? And so a common mistake I think you could make is you could go, okay, if it doesn't match any of my patterns, I also would probably want one for like is number, right? If it doesn't match any one of my patterns, then I've got a problem. Oh, sure. Radix would be 10? Yeah. I don't know why it's not default 10. Sure. The radix here for hexadecimal you could also do. You see OX and you change your radix to be 16. Anyway, if it's not one of these 3 patterns, and these ones are really the only ones I support right now, right? Then freak out and go, oh my gosh, this isn't... actually, no, let's do this. Let's freak out and go, hey, you can't have this symbol. Then you find it just won't work, right? Because you can't do 3 plus 2 because there's no space there. There's no space separating the two, right? Also, 3 plus 2 is kind of a really big reason where you have to be very careful with passing, including positive and negative numbers as part of the literal. Because if I include, negative as part of the literal here, I'm going to read this as 3 and then minus 2. Right, rather than 3 minus 2, right? I'm misinterpreting what the symbol stream is. It's a bit more exciting now. It's a little bit more complicated. It's really slow because it's really boring at the beginning. And my brain has like no motivation when something is boring, which is one of the reasons I'm streaming it, because I will not do this. Like, I've wanted to do this compiler for like probably like 2 or 3 years now. I've done like smaller versions of the compiler, and I've never sat down and done it properly. So I was like, if I stream it, then I have to, because then if I just like stop and like play a game for an hour, I feel like I'm being less productive. My voice is dying, so there's a good chance I'm gonna finish in the next 30 minutes. So, if you want to get notifications, I guess you can follow. No promises on when I will stream next, other than probably on Saturdays. I may stream tomorrow because it's kind of fun. Alright, okay, so if I don't have any of those symbols, when do I want to break? And the big consideration is, hey, what tokens are invalid here, right? And basically, any token that I'm not going to match to normally, I'm going to fail anyway. So if I do 10 followed by $sign followed by 2, $sign is not a valid token in my case. So I'm just going to fail on $sign. I'm not going to combine them or anything, right? And so there's no real point worrying about it too much because I'm just going to fail here. So instead, what we want to do is we want to try to look at tokens that are valid in terms of like things like, for example, underscore is definitely invalid, right? I mean, in our case, we're going to skip underscores for numbers, but like an underscore, if you can identify, would be invalid. For example, A would be invalid, right? Because this isn't a separator. So effectively, we have to define what's separating our characters and what isn't a valid separator. Now, we're going to be a little lazy here, right? Just a little. And we're going to say, okay, if C is alpha, is not alphanumeric, sorry. I think is this? I can't believe that came back to me if this is correct. Am I correct? The suspense is killing me. Oh, I gotta do this. I am not correct. What is it? I thought it was that. Normally it's like is ASCII is what you type. Yeah, is ASCII alphabetic? Oh, I said alphabetical. Okay, so if it's not, oh, so if it isn't ASCII alphabetical, then we know we got a problem, right? That's basically it. Or it's a digit. Now, why do we do this? Well, basically, this is just future proofing for our radix. So when we increase our radix in the future to like, let's say, or we decrease it rather, let's say we're doing binary, like O's and zeros and ones. If we get like a 4 here, right, we want the 4 to fail. Because, you know, doing 0, 1, 4, or 5 will fail. So we're just going to future proof this, right? It's okay to add future proofing like this, in my opinion. Because it still reads fine. Sure. This is. I don't know how we're going to error here. Do I care? Okay, let's just do it this way. Can't create numeric literal due to invalid character. I don't want to say symbol here, but sure. It's not a symbol. Just say C. But C is so. I'm just gonna say raw. Yeah, it's not even complicated. Entire symbol. How about I just give you an entire? Like I was gonna try like separate it. I was gonna try to separate it up so that you had like you could say like Q is invalid. Inside your the light has gone dark. I am in darkness. I was going to try to separate it up so I could say, hey, you know, you got an invalid character in your numeric literal. You know, we were expecting, I don't know, let's say the sequence 10, right? And you added like an A. The A is invalid. I think if I just say cannot create a numeric literal due to invalid character, then give the entire invalid sequence, it'll be fine. There's actually a really nice way of handling errors here that we'll come to later. Probably, I think. Alright. And then here we can just, guess what? Ta-da, we can return our result. Right? Wow. Insane. Breaking the boundaries of modern physics. Here we go. Oh, it's not the toString, it's the fact that I defined as a character rather than as a string. Fair enough. I was like, I thought you could add them like that. Numeric hint. There you go. No, you can't add it like that. I do have to do the toString. This is the kind of the nice thing about Rust. Okay, sure. It's kind of weird though. It's the nice thing that it's very easy to figure out what you need to do. Like typically the compiler will kind of tell you, hey, do this, do that. And even in this case, the compiler isn't, I'm just figuring it out. But you know, I still feel like that's kind of weird. I don't know, it feels slow to create an entire string to then pass in. I don't really know though. It's very hard to tell for us how the performance of like this looks like without looking at the raw assembly. Like, does it elide the creation of the string and just basically chuck it on here? That's basically what it comes down to. Well, we could probably see. Is there another method? Num string. Okay, so if we have a string here, what does this look like? In saying that, it's probably got a small string optimization, so I'm probably carrying too much. The small string optimization will be fast. Yeah, I am carrying too much. I mean, maybe I am not. Maybe it doesn't use a small string. Really? Huh. Interesting. So you can't have small string optimizations with Rust strings. That is really weird. Weird. Okay. It's just slow. Probably means I'm going to have to change everything to use small strings. Why? I mean, let's be real. I want to change everything to something called interning, which is the concept of like grabbing the string and effectively like having like a hash table of all possible strings. So like rather than having like unique versions of the strings, you can just check if the pointers are the same, check if they're the same value. So basically you have like one copy of the string that you share. The reason why it's better is because if you're doing a lot of string comparisons, it's cheaper. And also there's a bunch of other reasons too, but like it would be nice here. Yeah, the main reason is that like obviously if you've got like a huge number of strings, you're having to hash them each time and so on. It's pretty expensive for a compiler. And so just doing like a single, basically like the cost of a single hash once, and then storing that is effectively what it becomes. It becomes a whole lot cheaper to hash table it and stuff. But I don't really know. I would have to measure to really determine. I think that's something I can deal with later. How do I push to a number? I think I can just do like a push, is what I thought at the top of my head. I'm just going to say push. It is push. Okay. Sure. You know what? Screw it. I don't like it, it's this weird thing where it's like the character is consumed, right? So you do actually want to update your position. I'm just gonna write it this way. I think this will be easier for us to deal with. And honestly, let's do it this way. Okay. That's fine. Okay. This is the same thing as well. Yeah, okay, it's lowercase. I always forget it's uppercase or lowercase. Yeah. This is fine. Okay, so the idea behind this is basically what we're doing here is we're going, okay, we've matched our exponential, and then now it's also matched our our plus and minus, so for this case. But you can't have a dot here, right? Because that doesn't really make sense, I don't think. I don't think fractional exponents is something that's typically supported. You know what, the easiest way of checking? Let's just do this. Okay, 2e2. That works. Sure. Let me just do it this way. That works. 2e2 works. We get pass. Its type is 0. Sure. X has a valid variable name, and it's a float. So we can see it's f64. Looks all good. Awesome. Okay. This is very boppy music. Oh, didn't we do that? Sure. Next one. It's not very good, so. The biggest annoyance of this is the song thing. But you can see you can't put a dot here. This is invalid, right? So that makes it easier for us, thank God. Not by much, but a little bit. Okay. If you reach none, we're also this case. And basically we're just going to stop the string at this point. So regardless what it is otherwise, if it's C, we're just going to stop. Like, it's peaked, right? There's nothing else to do, right? So we're just actually going to break out of this loop. Okay, and then we need to return the value here, and this return value will be here. Oh, that's so cool. Does that actually work? Let's see. Let's see, this works. It does. Look at that, beautiful. So if we reach EOF or we reach something similar to it, we're just going to stop. Because we've already checked the condition where we get an error, right? So in this case, we're fine. This is just our exit condition. Now, obviously, the actual fun condition about this is this can actually become basically our where condition. Where we say, hey, where this isn't true. But I actually am fine with this loop match kind of paradigm here. I don't really think it matters enough to me to change it. I think this is complaining because I don't have... Yeah, I'm not covering all cases. So, yeah, otherwise I don't really care. So if we've matched these two, then we can actually push them on top as well. And this is fine. We're just going to ignore these characters. Then we're just going to pass the next one. Now, the one big thing, however, is that if we've seen the exponential, you may go, oh, but you can't do 1e. Right? Let me drop here. Right? That isn't valid. So after E, there needs to be a digit. Now, there's two things here that we could do. One is we could actually solve it within the AST, so it's actually a valid interliteral, and it's just later on that we validate it. Or here, it could be very, very simple, where our exit condition is basically we go, hey, if you receive nothing, right, and... Oh, sorry, if you get anything, I don't really care what this is. So these are going to match first, right? So if it's this digit, it's going to match here, not get to here. So hey, if we've seen exponential and num dot, maybe it's the last. That's kind of clunky. You know what, maybe nicer is just doing it here. Yeah. Anyway, it's fine. We're going to do it that way then. Let's go. kind of clunky, but it's fine. My stomach just growled. I need to go eat some of my stew. Okay, so yeah, I don't know. It's a bit clunky here, isn't it? So here we can basically say, hey, if this is a digit, we can say, I guess we could just say like, see how clunky it is? Like, because we want to do like an if let, and then we also want to do like a condition. It's like very common. So I'm really annoyed that they haven't done that yet. It's been like 4 years. Like, please. Like, you gotta just write like this really clunky way, right? We go sum of C if C dot is digit radix. Funny enough, the radix of this is also different. But you can have what's called a wait, really? The fun. What do I want to do? I want to do like a match conditional variable binding with if. Rust. Wait, maybe we can do this. I tried this before, I think, and I got an error. I did get an error. Look at that. Wait, the match condition states that the arm only matches if the value x is equal to 456 and if OI is true. Okay. This is just so clunky, right? I want like this. I guess I can say like C equals 2 or something. Wait, how do they do it? They go... What? They said like C at 2. Apparently this is fine. But like it's kind of weird, right? Because I was writing that. But I guess it doesn't work because it isn't within the scope of like the none character. Like you have to like say like this is literal value, like you're matching to this and then you're gonna bind it to a name. So it'd be kind of like here if I said if 0, at digit, I could do that. Like I'm binding the matching of sum to the variable digit, or like C here, right? I guess I'm just gonna replicate the error twice, right? Sure. It's small stuff like this makes it a little more annoying. Which probably means this could also be a break, actually. Anyway. We can also break from this. So this could break and return an error, which is going to be a Lex error, which is going to be, hey, this is an invalid numeral, and the rule is just going to be number. If it isn't a digit. Obviously this is because you're missing a digit, right? But yeah, whatever. And basically the exact same thing here. We have to fix these errors later. It's really clunky, isn't it? I don't like it. Anyway, fix later. Okay, done. So that's us almost entirely passing characters correctly. That's pretty good. And it's not much code. I guess this is test it, right? Why not? I think we have to use it though. Oh no, we have pass number. Or dot. Gotta remember that case. Okay. The dot could also be an operator, by the way. Frick, the dot could be an operator. I forgot about this. Look at that. Funny enough. Integers. Huh. Look at that. They must have integer part and rest. I'm not going to follow that. I like it like this. But if you have like E2, this just won't pass. So I think what I'm going to say, but I do want this to pass in mine. Because you could have like 1.e. Oh, that's true. Okay. You can't follow an exponential in this case. That's kind of weird. I thought you could do that in C. You can't. Interesting. And obviously you can't do this, right? That's just going to be error. Okay, so we will support this format though. So the way we'll do it is we'll say, okay, if you've seen a dot, the next one has to be a digit, which means even at the beginning, this one has to be a digit, right? Which is basically just this. It's really clunky, right? Like all this time, we're checking whether or not something's a digit, right? So I actually think, funnily enough, what we actually want is this. Consume digit, right? And this will basically say, hey, consume me a digit, right? And return the digit, or return the Lex error, right? Now, I will want to refactor this. This I don't like. This should probably just be an option, but it will make it convenient for me to write this kind of code. So basically this code just goes here and goes effectively here, right? I'm just going to like pass in a real number. Sure. Pretty cool, right? Which means he's pretty bobbing. Can I just write it like this? I can. Look at that. So now I can say you can't write it like that? Okay. That's one of the reasons I like doing the for radix thing, is that it makes it more readable, right? Because you can kind of, you don't just have this like random number nowhere, right? You can actually like, what the heck does 10 mean, right? That's okay. I can just check radix here, and it's readable enough. So now I consume a digit, and guess what? If this fails, bang, this is going to return. Look at that. Oh, okay, sure. I have to like first like capture it somewhere. It makes sense to some degree. Wait, what? Cargo, tell me what's wrong. Oh, that definitely makes sense. Oh, it is here. I'm just stupid. And this just needs to be a, I mean, it really shouldn't matter, but I will do a copy. Which means I need to do like a, I think I can just go to string again, honestly. That would just copy the thing. Oh. Yeah. I choose string, we'll just copy it here. There's a better way of doing it. And again, I think I'm going to come back to this, because I think the way I want to handle this is a bit different. But I just got to think about it a bit more. But consuming this here is not very nice, because now I can just obviously pass by reference. But that's a very useful error. So saying like, the difference is though, in saying like C++, you wouldn't have had that move happen, because the move would have had to be explicit. So in C++, you would have had to say like, move this, right? And then that action would have moved number, right? So you wouldn't have had this implicit move of number, which is what's happening here. It's personal preferences, but I do think it's important to recognize that like, we don't want to go overboard on either side of the conversation, right? I should be able to do num to push here. We don't want to go overboard and go, okay, you know, this would have been an error in C++. It wouldn't have been an error. Like this would have been fine, because it would have just passed the structure by reference. But you probably would have had a pointer to a string anyway at this point, like a constant char or something maybe, or just like a literal std string. It wouldn't have caused a move. Maybe a copy, worst case, but probably not a move. Do I need anything else here? No. Okay, I'm gonna stop in a couple of minutes. So, sorry. Hey Lego. I am bad at reading chat. Trying to figure out a language to do math and finance things. Is it better to program on a Mac? This is a Mac M1 because I don't know. I'm edgy like that. No, not really, but like Mac M1s are good. I love them. They're really, really, really fast. Like I have Parallels running on this computer, and it's pretty much just Windows flat. I actually use that over my Windows laptop for work in a lot of cases because it's just as fast and it's a bit more convenient. I love them. They're like $1,000 and they're absolute like just really fast, but they are much more work. So I've had to compile things completely manually myself, right? I've had to from scratch compile a what's called an ODBC library. So for example, let's say you want to connect to a SQL server, and SQL is just basically like a big database, like a big spreadsheet, right? It's got a bunch of tables and stuff. If you want to connect to a database like that, which we'll probably do eventually, text is covering my face. What you have to do, I've got so much energy now. What you have to do is you have to have what's called an ODBC driver that basically lets you kind of connect to that server. There's many other ways, but that's the typical way. And the thing is, that's really kind of a system architecture thing. So what that means is if you're dealing with Windows, you have a different driver than if you're on Mac, right? And so the problem with Macs is that with the M1 and stuff is that these drivers don't exist really, and so you often have to compile them yourself, which isn't a lot of work, but it's a decent chunk. They'll exist eventually. I would say Macs are definitely convenient. They're a lot easier in some ways, in other ways they're harder. I think it's personal preference. I wouldn't really worry. I would say it basically comes down to how much you want to spend. You know, Windows computers can sometimes be a bit cheaper, but typically for high-end ones, they're about as expensive. Oh, I will use this in a second. Anyway, but yeah, and then your other question was trying to figure out a good language to start with maths and finance things. Honestly, I mean, maybe I'm going to be a bit of a rogue person here and say that Python is better. Because Python, I think, in my opinion, is if you're going to do anything mathy or financy, R is good as well. I really wouldn't go more than that. If you try to write a lot of math in Rust and stuff like that, you probably won't find much benefit over Python. Python's just really easy, right? So if you've never done programming before, Python's really easy to begin with. Whether or not it's the best language to begin with if you want to do other programming is a completely different discussion, right? But I would probably say Python. Yeah, it's a bunch of stuff you can do with it. Like I do study physics, so I've typically got a ton of like physics notebooks that maybe I'll go through at one point later in the future, right? And basically you can do some really cool stuff with it. I've got like visualizations that will let you like kind of take a simulation and go forward and backwards in time with it, and it was like 10 lines of Python code, right? If I was writing that in Rust, it would be like hundreds of lines, right? And so that's kind of a big downside of using these, what I would call heavy lifting languages, is that there's a lot to lift, right? Which means that you typically write a lot of ceremony, you write a lot of kind of boilerplate, you're writing like a lot of code just to do very simple things. And in Python, you don't write any of that, but you also don't get the performance benefits of writing that, right? You're losing that context. That context gives you speed, it gives you safety, it gives you maintainability, right? But it's slower to develop, right? So you kind of have to balance those two things. Also, let me know if the music's annoying. I don't know, man. I don't really listen to this kind of music, but it's very, very boppy. It's nice. It's decent music. It's not terrible. It's just like very much like free music, right? That kind of vibe. Low-key missing Spotify. But I also do not want like the entire American Film Federation on my ass. So like, I think this is a fair system for that reason. Any expansional has tab even plus. Yeah, okay, sure. So we're just gonna say self.consume digit. So hopefully that answered your question. Sorry for being delayed. I don't know, that was probably a while ago. It's very I get like I look at chat quite a bit and then I look away when I'm focusing. Anyway, yeah. This is good. So one thing that's really cool with programs obviously is going to be thank you. That's actually a really nice error. The nice thing about this error is what it's saying is saying, hey, you have a result type and it could be an error and you're not handling it. And so by adding the question mark here, it doesn't care that I'm not handling the value, the result here, this char. It doesn't care that I'm not handling this. It probably should, but it cares that I'm not handling the error. Now, in my opinion, it should. Is there a way I know there's a way, like, typically in C++, if you're writing this, you'd say, what's the term? It's like GNU don't drop or something. Anyway, it's like a special attribute that you can say. You can say, okay, this is a value that you can't just ignore. You have to use. Oh my lord. Yeah, let's go chili because I have enough energy. I don't know, man. Who knows? Alternative rock, why not? I don't know what the hell alternative rock is. I listen to very basic music. Because I am too busy to care too much to be. So, if it's decent and has a decent bop, I'm typically up for grabs. Push the consumed character, that's fine. Push this one, that's good. Push this one, that's good. Is this done? Are we handling any case incorrectly? No, I think we are handling every case correctly. We force a digit after the full stop. Am I spelling smoke or just backburning? It's welcome to living in Australia. Is this an intentional fire or is my house currently on fire? I don't know. Does kind of smell like smoke. I'll be back in a second. Let's see if I burnt down my house trying to make a stew. I have not burnt down my house. It was just a very nice smell that kind of was a little crispy, you know, that little crispy kind of like potato feel. I cook these like really fancy potatoes. Every time I try to do something different. I'm doing these like French potatoes now. You get like this like really nice creamy sauce and you kind of like cook them in it and they go soft and anyway, it's very nice. Anyway, I'm completely unfocused. What am I doing? That's fine. Yeah, we're doing hints here. It's a good vibe. Sure. Why not try and see if this actually works? It builds? That's always a good start. Does it run? It runs. Okay, so we haven't broken that code. That's good. Let's give it some actual real input. And by that I mean a bunch of numbers. .2 .e. Okay, let's try that. Oh, I don't have to build each time? Okay, that would be nice. So this maps and the hint is correct, this maps and the hint is correct. Oh, look at that. And what if we do an invalid thing like .e? Or does it work? Oh, look at that. Beautiful. It maps an numeric integer invalid character dot and then it keeps going, right? So normally you would like reach this error here and you could stop here, but you don't have to stop. That's kind of the beauty of this, right? It's I don't have to stop, I can keep going. I probably, if we are going to keep going, I probably want to change slightly how the number passing works, just ever so slightly in terms of like, sometimes you want to actually, even though it's an error, you still want to consume the character so that the next token lines up a bit better. Anyway, what if we just add an E at the end? Does this break? It passes successfully. So that's a case that we're not handling correctly. Oh no, it doesn't. I can't read. It's a numeric literal invalid character. So that's very interesting. I'm just noticing that now. It's adding the character twice. Okay, that's a bug. Why is it doing that? It's probably pretty simple, right? It's probably just this consume digit should push it, and we're not pushing in the case of consuming. We're not. Look at that. Look at the wonderful. Okay, because this is peaking, right? No, well, actually, honestly, this doesn't even need to be peak. This could literally just be next. Because the reason why it can be next rather than peak is because, like, we're consuming a digit, right? We're not just, like, grabbing or seeing if there is a digit next time. We're saying there needs to be a digit, else raise an error. And when you're doing a case like that, it's presumed that you're going to just consume it. So now we should get just .2. We do, look at that, wonderful. Okay, so I think it's probably a good idea to just start off and just talk about how testing works with this kind of stuff, right? Now, there's a few ways you could write tests, if I remember. I remember you can do a different test package. That's kind of what I want. A lot of this is me learning Rust as well, so hopefully that will be somewhat useful because it means that people will also learn Rust. From like the fact that I don't remember everything about it. I haven't coded it in probably 2 years. Okay, that's good. And we can run a specific test. But I want to know how to create a test. Yeah, I know I can just create a random thing. Oh. That's awesome. Yeah, let's do that. So I can go like this, and that will create a tests lib. Genius. Look at that. I don't really know how I'm gonna grab. I think, can I just grab my crate? I presume I can. It works. It does work. Look at that. Wonderful. I love the fact I can press this run test though. That's gonna make my life so nice. Okay, it works. Sure, let's just change this slightly. So what you want to do is you want to grab a crate called DAP. That's our base crate. And then we want to grab inside of DAP and say, hey. Now I think to do this, we'll probably have to create a lib. We actually probably want to like grab the Lexer and all that stuff and actually pull it out of the compiler. So this is going to be a bit annoying. We're going to have to go, hey, I'm going to call it core. So we're going to grab the core. I will not grab core. That's a valid complaint. We'll call it DAP core. So this DAP core can contain all our library code, like this, for example. Right? And then this just has to go, hey. And I want to put my test in a different directory because I do actually want to like, I want to test like the black box of the implementation, not like the raw internal details. Again, I'm literally exposing the entirety of everything here because I'm going to come back and deal with that stuff later, right? But look here. What I do, create DAP core, maybe extern crate. Okay, and then I probably need to add it to my cargo. I think I can literally just say like DAP core here. How do I do this? Reference. I know you can do it very easily, but I don't remember the syntax for it. It's like a local crate is the definition. Oh, that's very easy. Okay, awesome. I know I can do this in the way I want to do it, but it's kind of clunky. Let's have a look here. How do I include it? Okay, that should be fine. I do think I need extern here. I think the problem it hasn't built the crate, so I think that's the problem here. Yay, look at that. And the reason it's built the crate is because this error needs to also be in this cargo. It worked. Oh. Does it run properly? Beautiful. I mean, it doesn't seem like a lot, but it is a decent chunk to have that work instantly. Now, I like exposing my tests outside my classes, for as I said before. You know, we're going to write some really, really, really nice tests, but not right now. Right now, well, okay. why don't I show the power off of macros, because that's actually really cool. Macros are like kind of, I would say, one of the critical parts of what makes testing really convenient. So the first thing I want to do when I'm going to define a thing here is I actually want to look at, see all these token types and stuff? These are fine to be here, but I'm actually going to grab all of these and pull them into a different class, into a different file. I'm going to pull them into the mod. Which probably means that a bunch of this stuff has to change. Like this. This probably has to be at the top. And that is like the opposite of what I wanted to do. But then this probably has to come in by this, I think. I think I can like go like use create. I know I can do it like this way. That's kind of clunky, right? Yeah. It's like I'm using the outside area. I'd rather just like say like, I guess I can just say like use create Lexer, which is literally ourself. It's kind of weird though, right? I'm not like, that's like weird as hell. I don't know. Weird. We can probably fix this. So let's make it cleaner. No matter. I don't know. I don't remember how to do that. I don't really think it matters too much. I think I'm gonna say that a lot. I don't think it matters. Okay, so now the reason why I'm doing this is so I can actually create a bunch of like, well, I actually like calling them like, I typically chuck them in like a macro class, and it seems weird, but the reason why is because I basically want to be able to define a bunch of macros. Okay, sure, macros. And this just makes it convenient. Now, testing macros will go in the testing place, but the point of these macros is to allow me to basically define these kind of, define these Lexer tokens I just had, right? All these kind of Lexer tokens we say in the last, what, 3 hours almost writing, right? And be able to create a very nice kind of compiler representation that we can write so that we can do it like this. So we can say, okay, run test, give it some input, and say that this has to match to a token stream, which is an array of characters, and the first one is, for example, a punctuation of open 0 like this. I want to be able to write it test like this. Isn't like this really clean? I mean, obviously there's going to be one more punctuation, but like that's kind of the whole point of this, right? So rather than me having to like, it seems weird, you go, oh, can't you just create these objects anyway? But like when you're kind of able to create tests like this, it's very nice. And it's not really a good case in this one here. It's a much better case when we get to types. When we get to what's called type inference, and we can say, okay, int x, or I don't know, x is equal to 2, right? And we want to check what the inference's type is. We can go, okay, instead of writing all that kind of annoying code, let's do type inference this way. Infer. We can say something like this. You can go, okay, if you have a raw type, like for example int, right? Or maybe we call it like primitive, like prim int, and you are unioning that with a, I don't know, let's call it, well, really it's just an unknown type, which we're just going to call placeholder. Then the result of that union should equal, I don't know, I guess that arrow is fine, should equal prim int. But more importantly, the placeholder u should equal prim int. So what we should actually get is we should get two things. We should get that u is now equal to prim int. This seems weird. This is a very simple case. Let me just do this so you can actually read a bit better. It seems very weird why we're writing types like this. You go, what do you mean? Well, you're saying, okay, if we have a primitive int on one side, and on the other side we got u, we don't know what it is, it's just like x equals int, right? Then we need to make sure that we set u to be type primitive int. And this may get very, very complicated. You may have like a function that takes an int and returns a placeholder type. And this would be a primitive, right? And this is union with a function that, guess what, takes a placeholder type and returns a primitive float. And now we can union two things. So we can make sure that A gets set to float and B gets set to int. And this can get even more complicated. Inference is not easy. We're going to probably use something called hidden and minly, but it's pretty cool. And so the benefit of writing like this is that you can basically write very, very complicated type tests, in this case, in very few lines. And you're not writing strings, they're all typed in short, and you're actually physically creating the objects. This is a macro that will expand and will physically create the objects and then compare the objects. So you're not writing code any differently, but this line of code can change into like 100 lines of code, which typically, that's not 100, but it's about 20 to 30 lines of code is last time I did a type inference algorithm and I did this entire thing, it was about 20 to 30 lines of code per something like this, which is a lot of code and type generation to check these differences for just a single line of code. And I ended up writing like 100 of these, and that would be like, what, 2,000 lines, what, 100 times 20 is, yeah, 2,000 lines of code. I don't know why that was so hard for me to think of. That's 2,000 lines of code that I wrote in 100 lines, right? This is kind of where I love Rust. Rust has such perfect ability to kind of handle type tests, and not just type tests, any kind of test. It's one of the things I think people never really talk about, is the fact that you can write testing macros that just make writing tests infinitely easier and a little bit more fun. Yeah. Making things fun is always good. Okay, so we were distracting ourselves there for no good reason other than just so I don't have to write this. And the general idea is that you want to do a macro export to say, hey, this macro can be exported. It's going to complain because it expects, a macro to be exported. And then we're going to define macro rules. This gives us the ability to define some rules about how our macro is going to occur. Then we're going to give it a macro to define. And I'm actually not too fussed how I do this. I'm just going to be a bit lazy here and go create macro kind here, and we'll come back to this. And so the first one is obviously going to be a separator, right? So separator is pretty simple. It basically is just, a separator. So we can say, hey, grab my Lexer, grab my punctuation kind, and grab my separator, right? So what that means is if you write this, right, it will transform into this, right? So I've written probably more lines of characters to do the same thing, but the point is that I don't need to call this function anymore. I can have macros calling this function when they want to create a separator kind, right? Anyway, let's keep going. So the next step is obviously going to be open, but we need arguments. So what do? Well, we need a depth. What's our depth? Our depth is going to be an expression. Why put expression here? Why aren't we putting like an integer? And the reason why is because this is a macro. This is operating on what we call the AST. This is not operating on the underlying. This is operating on like literally like the Lexer. Like the Rust's Lexer is going to be using this effectively. Not really. It's a bit later than that, but still. Which means it's operating on the literal AST itself, the literal structure of the program, rather than the interpretation of the program. So rather than saying 3, it sees it as an expression. It sees it as an integer literal. So it kind of is one higher level. So it's almost like it's seeing tokens. It's not technically tokens. It's like chains of tokens. So for example, instead of seeing 1 plus 1 as token, 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 it would see this as a single expression. And this expression would be like probably a binary operation expression, which is composed of, the binary operation plus, as well as, 2 integer literals. Okay, let's keep going. And then we want to keep going. Open. And then guess what? Depth. It's going to go and chuck this integer in here. Replace. Done. Alright, my energy has just come back. I have very weird energy cycles. Okay. Let's actually get into the meat and potatoes of this whole thing. Bang. What are we going to do? Well, we want to create a token. We're going to call it Tok. So you're going to say tok with an exclamation mark and it's going to create a token. It's quite short, it's good, it's nice. What's the first case for creating a token? Well, the first case is going to be EOF. Okay. So if you write it like this, you're creating your token. There's your EOF token, right? Okay. What's the next rule? Well, the next rule is going to be a character. I'm teasing you a little bit with the whole getting the punctuation kind because it's a little bit harder, so we'll delay it so I can kind of remember what we have to do. I briefly remember. We'll see whether or not we have to Google. I'm pretty sure all we have to do. Oh, screw it, I'm just going to do it now. I'm not going to make you spell the full thing because I'm a maniac. I'm pretty sure. So the first step is obviously going to be the punctuation like character, which is like less than greater than. And then I think what you have to do, we want to make it repeat. And then you want to make it have a bunch of inner tokens, which have to be TT. And then you don't really care about the repetition. Yeah, that's it. So the idea of this is you're saying, okay, this plus means you need at least one token. So you need at least one thing inside of it, but we don't care. Keep in mind that we're not doing expressions here because we're basically just going to grab everything for the separator, right? And the thing is that it has to be surrounded by braces. So what we're going to do is we're going to have a punctuation that comes in like this. You're going to give us a type. And then you're going to give us an inner, which is going to be surrounded by parentheses. And the inner could be, for example, anything you want, like open or separator. So what we're going to do is we're going to take all these individual little tokens, which is what TT means, basically. It's a token tree. And we're going to take all these little individual components, and we're going to say, okay, just chain them in between parentheses. So it's going to count the parentheses for us, and then that's our token. And then what we have to do is we basically just have to expand that in such a way that we call the other function. That's it. I'm actually going to say token type here. It'll become more apparent later. Token will have a span, or like be a spanned address probably. I don't really know. I'll figure it out. Vibing. This is like this, isn't it? I think it's this. And then to call this, we just do this. And the plus here basically means add a space after each one. I don't know if this is complaining because of the place I'm putting it, or whether or not it's complaining because it's an actual error. We'll have to find out in a second. Also, I have to remember what punctuation actually is. Yeah, it has a raw and a kind. Yes, I am right. Okay. There's more, but let's stop here. And let's define our test for our punctuation. Just you know, why not? Okay. Give me my DAP core. Frick, I forgot how to define it already. Sure. Okay. There's my TOML. What's my test going to be? Let's do a balancing test. Right. Now, oh, this is just a token test, I guess. Delete this, basically. Delete this later. This is just going to test whether or not our macros are correct, basically. Which you should really need to test. Because I'm just going to test whether or not the macro... I mean, maybe you could test it. I don't really know, man. Up to you. I think I also have to say, like, use macros or something. I don't remember. I guess we'll see. What does it say? Sure. Maybe this is fine. I don't know. EOF. What happens if I say EOF? I probably am not testing my testing. Just say running 0 tests, right? I'm not going crazy. So what do we have? Running Dapper and running this target. Okay, why are you being weird? Do I really have to specify? I feel like it's not. Shouldn't be this hard. What am I looking for? Do I want to give a package? Maybe I do want to give a package. Maybe not. Oh, is it target? No, target's the target I'm outputting for. Run test for specific crate. I guess I could just cd into the crate directory and just do it that way. Why not? So the thing about this is this doesn't go back out again because it doesn't exist. But if I do this here, see this because it's inside this directory, so I got access to the crate directory. Which is probably also why it gave me no hints because it didn't know. Yeah, look at that. This needs to be an external crate. And I think the reason also why is that I'm not exposing macros. Consider in exporting this macro. I thought I did, didn't I? Am I stupid? I am stupid. Oh, it's literally in the raw DAP core. That makes a lot of sense. I am exporting it, my dude. Use DAP core talk. Do I export like this? I definitely don't. Good, okay. Import macro. I think I need to do something special like use macros, I think, is what I need to do. Because if I don't think, say I say use macros, it will not let me do it. Beautiful, that's it. Thank you, Stack Overflow. Or not. Oh, I literally copied that code. That's why you don't copy from Stack Overflow. Maybe I go like truck this over the specific import. Okay, so that's not it. It recommends I can also do this apparently. Yeah, see. Oh, because... Oh, I just deleted it? Oh my gosh, that's such a funny mistake. Rust. fun, isn't it? Ugh. I thought this would work, because the talk here should be fine. I do say macro export, don't I? Yeah, I was like, I normally have to do this, right? And normally that gives you access to use the macros. Like, it's not giving me an error, which is making me think it's fine, but it isn't. Which is fine. Oh, so it builds, it just doesn't run test. What? That's so funny. Oh, I need to also include it here. No, that's not true. Why would it be erroring here? Fun. If anyone has any clue, please feel free to. I feel like it's something that's doing. Oh, I know what's wrong. Sometimes I'm stupid. This is actually needed, because this has to come from these. So all these Lexers here, the problem is, this is actually a valid error. I just am not reading it. As soon as I read this, I realized what it was. So the problem here is that it says this originates in a macro, right? Which means the error is actually originating here. It's just not telling me that, which is lovely. And it says, hey, you're trying to access Lexer, but you don't have access to that. So really, these should be create Lexer and so on, right? So the easiest way of doing is probably to say pub mod Lexer. Can I just define mod Lexer? I guess I can say like use Lexer. Like, it's literally here, my dude. I guess I'm just gonna do the cheeky thing, which is like, well, there must be a better way. Access properties defined in mod.rs. I guess I can say super. I don't hate super. Super's kind of what I'm looking for, to some degree. It's still like weird, right? Yeah. Oh, you know what's happening? These are happening at the... The problem is that they're actually happening here, so it's trying to resolve them here, which means the paths aren't matching up. This is kind of, I guess, the inconvenience using macros, right? Is that you presume things are imported. I guess we could just, like, presume everything's imported. It's a weird presumption to make that I don't like, and I think we should fix later, but I'm not going to bother fixing it now. To do. The reason this is weird is because we rely on this stuff in the context of the macro. It's a little clunky and could be fixed. Okay. Works. Kind of. Actually, it should just like have the token type already. Like that is something it should need. We shouldn't need to do. The token type should just come from here for the same reason that punctuation comes from here, right? I guess I could just like presume that you've got a similar structure. I don't really know if it matters too much. Let's just do this, see if this works. We're creating EOF, aren't we? So why don't we just do this? Yeah. Okay. It actually worked, by the way, if that wasn't clear. That's kind of really weird. So like the reason why this is weird is that like you want to refer to token type, which you can kind of do here, right? The dep core, you're importing everything from dep core. I guess dep core doesn't have token type inside of it. Is that the problem? Maybe I'll go get like create level. Oh, look at that. Works. It's definitely more clunky than I remember. Anyway, it's fine. I guess we should do... I think I'm happy making these all dep core. Like that's the system they're under, right? So like if you're exporting it from outside of this, which you probably will, like this is the point of this, is right? Is to use it outside of it. I'm sure it's a better way of doing it. I'll think about it, and when we come back, I'll probably would have changed it by then. I think we're basically going to end this here though, other than maybe defining very quickly a equality operator on our token type. Wait, why do we have punctuation here? Oh, I was showing that off. Okay, yeah, that makes sense. Okay. It worked. Look at that, they're the same thing. Anyway. Don't need this. I do need this. Even though it's emitting warnings for this. What am I doing? I'm actually doing something wrong here with how the macros are treating it. Because like they're not needed within this scope, but they're needed within the macro scope or something. I don't know, man. I guess what I could do is I could like, I don't know. Macros refer to their own package. Then have like a rust here. I'm sure what's happening is pretty small. Is that really all we need? Sometimes people come up with things that are quite clever. I mean, I don't think this will work because I think that... Okay, well, I clearly don't know anything. And, I mean, I tried to remove this before and it wouldn't let me. Yeah. So I don't really know what these warnings are about then. at least it's much more consistent, right? I guess cargo test warnings despite use in macros. I don't know, it's just like clunky, right? Oh, I guess maybe what happens is if I run tests, I don't see the warning. So I guess maybe if I like go cargo test and do what they said, where you say profile test. Well, apparently I can't because I need unstable options, sure. But like if I do something like that, maybe it's fine. I don't know. I don't really care enough. I think the fact that this works is cool enough. Let's create our token. Punctuation. And then what's inside of a punctuation? Well, let's say the left character. And then, I don't know if it's a string or not, I don't remember. So we're not gonna care too much. And then inside this we need a punctuation kind. Which is open. And this will be false. I was just not running these tests, I guess. You can see it's not running them. Who knows? It runs if I do it this way. Right? So you can see here left and right. So the left is punctuation with the raw equals to this and the kind equals to open, and the right side is EOF. So this would be, for example, you know, punctuation with raw being this, kind being open 0. So hopefully that kind of demonstrates to some extent what I'm talking about. Don't know why this button test doesn't work. Probably because the scope is running the dapper test rather than running the individual test. Like this is probably scoped wrong. There's probably a few bugs around like how Rust is definitely not really like that, you know, mature yet. It's definitely, I would say, a little bit mature in terms of the approach of some things. Like that's really awkward, right? I don't know. I guess I could just say like, yeah, can I disable this because I really want to. Allow dead code. Anyway, I'm probably going to finish off about here once I get these unused stuff goes away. There we go. I don't know if I have to do like this. I think I do. It's fine though. Okay, I'll just put in a new line because I don't really care. I'm sure there's a way to do it without needing to do this, but yeah, it's fine. Yay, look at that. That's much nicer. Who needs errors? I think it's fine for tests to ignore errors. I probably wouldn't do this outside test. The reason why this is failing, by the way, what Google is effectively saying, was that this configure thing here is basically saying, hey, if we're not in test mode, don't generate this code. So it basically only generates this code in test mode. So I guess another way you could do is probably by remove that. That's probably fine, right? Because there's a completely different repository. So actually, we probably could just straight up remove that and then run it. But if I remove the test, it's not going to detect it, right? So apparently test also makes it not compile the code, because as you can see here, it doesn't compile, right? So I'm just going to accept this and accept the configure test. What can you do? But yes, this is the first step. But then the next step will basically be allowing us to kind of say, hey, here's a string, and here's what I expect the tokens to be. And it's going to basically just do what our main function is doing here. Spin up an instance and iterate through it. I mean, it really is not going to be that much code. But yeah, I think we're going to end here. Thanks for coming along. Hopefully you enjoyed some part of it. Bit of a slow day. What will happen probably next time, which will probably be tomorrow, is you'll come back and you'll probably see that most of Lexer is being finished. Like, there's really nothing left, as I said before. Really, I will do strings tomorrow, but there won't be anything other than just adding more tokens here. So there'll be identifier matching and stuff. It's basically just adding more lines to this code here, right? And that's it. So there may be like 20 lines of code by tomorrow. I'll probably do it tonight when I'm bored, if I get time. And we can come on and we can probably start building an AST tomorrow. I don't know. Depends if I want to stream tomorrow. I'll see how I feel in the morning. I've got a bunch of work to do as well. But hopefully, yeah. So follow if you're interested in seeing more of this kind of stuff. I don't know. I don't know if following really does much. I'm more just doing it for the fact that it encourages me to actually do it than anything. We'll see how it goes. And if you get any recommendations of things that you're kind of interested in, I kind of am mostly just doing this for the sake of doing something, right? So I really don't mind if you want to see how you'd write like a web server or something, I don't know, from scratch. That'd be kind of fun. Or something random like that. I will see everyone later then. I just have to like stop it.